En este trabajo que hicimos con Eduardo Zimmer, que es un gran colega que conocí hace muy poco, by the way, describimos cómo a lo largo de los niveles, o sea, de los niveles, por ejemplo, de la genética, de la epigenética, del esposoma, ¿no es cierto?, de los determinantes sociales, de los factores externos, de los niveles fisiopatológicos, no sé, el sistema inflamatorio, el sistema inmune, hasta los niveles cognitivos, afectivos, sociales, e incluso los modelos matemáticos, como los modelos de predictive coding o los modelos de whole brain modeling, ¿no es cierto? Absolutamente comparten dimensiones entre cuadros psiquiátricos y cuadros neurológicos, o entre la mente, digamos, la salud cerebral y la salud mental, ¿no? Por eso creo que necesitamos hoy más que nunca reconsiderar las líneas, y bueno, y hoy tenemos un excelente panel de presentadores. Vamos a contar inicialmente con Georg Northoff, que es una persona que ha trabajado muchísimo en los enfoques espaciotemporales del cerebro y que ha integrado enfoques de la psiquiatría, de la neurología, de la fenomenología, de la filosofía, de las neurociencias, del modelamiento computacional. Es una de las personas, de las pocas personas que conozco que maneja tantos dominios. Trabaja en ética, trabaja en self, y podríamos seguir así hablando de un montón de cosas, ¿no? Nuestro segundo invitado internacional es un hermano casi, Mario Parra, con quien hemos trabajado desde hace muchísimo tiempo en Latinoamérica para crear un consorcio, un enfoque. Mario trabaja especialmente en la demencia, en la enfermedad de Alzheimer, y ha desarrollado uno de los pocos métodos robustos y transculturales para identificar demencia en distintos contextos, ¿no? Es un gran investigador, pero hoy voy a conversarles de cosas que tienen que ver con este link entre mental health and brain health. Y después tengo el gusto de también tener con nosotros a gente de nuestro equipo, Claudia Durán, que es con quien tenemos el gusto de dirigir en nuestro instituto, y les va a contar sobre la alostasis. No les voy a decir qué es lo que es para que ella se encargue de hablar de ello, y también cómo es una herramienta que nos permite entender cuadros psiquiátricos y neurológicos, ¿no es cierto? Después Coti va a hablar de mindfulness y cómo podemos conectar mental health con brain health, que es algo también sumamente importante respecto a las intervenciones que podemos hacer en ambos lados, ¿no? ¿Me falta algún speaker? No, perfecto. Así que, sin más demora, le vamos a dar la bienvenida a George, que está escribiendo cartas de amor para alguien, y le vamos a pedir que pase a hablar. It's your time. I continue to make jokes, sorry. Perfect. Do you want to? Sure. Si quieren hacer preguntas, tienen que prender el micrófono.
Yeah. Okay, and actually, yeah, thank you very much for introducing. Also, thank you very much for inviting. I had a lot of very exciting meetings, so thank you for that. I really appreciate it on Friday and yesterday. So, and one notable thing is really that you know what dynamics is. It's very simple because in many parts of the world, people don't really know what dynamics is. So, and so we have a broad research program which really goes about brain-mind connection. And I show you today one particular line of that, and that concerns psychiatry. So, and we have this, and I will explain this model of brain-mind connection. That's a spatiotemporal connection, and from there we basically investigate also different psychiatric phenomena. And the main idea here is for psychiatry is really that we can say this goes into the sum of the tentatively the mechanism. Of course, I look at the computational people and they say, this is not mechanism, what you're talking about, and they're right, but at least tentative. And second, that also carries clinical significance, meaning diagnostic markers, and therapy suggestions, to which I come at the end. And I think that's where we really converge, that you pursue a similar line of research. So, okay. So, thank you very much. I didn't know that you do the job. You want to talk for me? Okay, good. So the main key is, and that's a little bit conceptual background so that you see where I'm coming from, because that's very important to understand or not misunderstand what I'm saying. So here, what we often do in current neuroscience, it's really, we're on the surface of the iceberg. We look for neural correlates of certain cognitive functions, attention, working memory, perception, motor action, which are observable to the outside. And then we look for neural correlates, and then Friston was so brilliant and said, okay, there's a computational mechanism, predictive coding, active inference, generative model, which I would say operate here. And then you say, no, this is not really true. Then you would say, Friston comes with the argument of free energy, but you would say the free energy should be between here and here, where it directly interfaces to the water, but that's not true. The free energy is calculated at the sum total of the prediction error. So it's ultimately here. So you need to really go into some of the operational details. So I'm looking here. Why? Because I think we need to go back to the deeper layers of the brain where it directly interfaces or aligns, you will hear that often, or encodes its direct environmental input. So again, here is the encoding, here is the decoding of what is encoded. Yeah, and I'm looking here, and you will see this is a constant theme of my talk, and it's important for psychiatry, and also I think it provides new views on the modeling. So you will see we do a lot of input modeling. So, and what characterizes these deeper layers where I say these are key for the mind, for the brain-mind connection. So that's really a different approach when you look in the current neuroscience, in the history of psychology and neuroscience. They always look for the mind up here. I can't even reach it. Yeah, they always look here. I look here. So I go backwards rather than forwards. Next one. So that's basically an overview. So I first, before going into the crisis of psychiatry, then I go into the spatiotemporal approach, what it is. Then I show you two examples of the spatiotemporal approach. Depression is a speed disturbance. I know this is all very strange for you. If you're coming from cognitive psychology or cognitive behavior therapy or from biological psychiatry, what is speed? It's trivial. Then schizophrenia is a temporal precision disturbance, and you will see I try to assemble a lot of evidence for that. And then I come to the conclusions from mechanism to diagnosis and therapy. Next one. So, very short, brief, in psychiatry, we even face more of a crisis than in neurology, and where you're dealing with, because next one. So, many don't know this. A quarter of all disorders are mental disorders. Yeah, I mean, sorry to say, the numbers for dementia are low. I think it's 20, 30 million. Compared to depression or anxiety is 80 million. Look at the funding, just as a side note. Yeah, the discrepancy. So we have to change that because the incidence of mental health disorders is increasing. In particular, very alarming among young people, in particular after the COVID. So this is not, so in 10 years, there was an estimate from the WHO, it will be by 30% of all physical diseases, not just 25%. And when you ask around, it's amazing. I remember that last year in October there was an article in a Canadian newspaper about our work. We were on front page, and in the evening I went to the supermarket and bought the newspaper. And then the cashier looked at me. Oh, this is you. She's asked, what are you doing? Yes, I'm dealing with anxiety and breathing therapy. Oh, I need that too. Yeah, so even the cashier, but just by chance, is unbelievable. Yeah, and 80% of many of them are anxiety and depression. Yeah, so it's really tendency increasing. So we focus, our main focus here, for the sake of pragmatism, but it will be extended in the future, is anxiety disorders, depression, schizophrenia, bipolar disorders, but we also include, for instance, post-traumatic stress disorder, because it's very important. Next one. So what is the challenge of treating mental health disorder? We have no markers. We don't even have neurological signs as you have. You have some symptoms which many psychiatrists interpret in different ways. So there's a saying, if you're 10 psychiatrists and one patient, you have 20 diagnoses. Yeah, so it's really, it's very problematic. There's a lot of discussion about classification, DSM, some of you might have heard that, the alternative systems. Yeah, so that's on the diagnostic side. So we have no diagnostic markers. Yeah, so it's a catastrophe. Then depending upon your orientation, whether you're psychodynamic or whether you're Freudian or Jungian or whether you're biological, you're diagnosed different. It's a catastrophe. And that continues with the drugs. I'm not against drug treatment, so if there's some pharmaceutical company people here fair, but the drugs they suppress the whole brain. They're not selective. So imagine if you have a broken bone here in your lower right leg, and you need to do some physiotherapy in order to keep the rest, the upper thigh and the other leg intact. Now the doctor puts a cast on both legs up to your body. So that's basically what we as psychiatrists do. Yeah, with many drugs. So, and we have a lot of trial and error treatments, and of course I don't need to, leads to a lot of suffering. Next one. So why is that? Because we don't know the mechanism. We have no idea about how this, we see abnormal neuronal activity on a group level. Many results cannot be replicated, let alone individual prediction. You have data sets with 1,000, 10,000 of subject, let's say in imaging or genetic, didn't yield anything. So the question is whether you just increase your case numbers and use more machine learning methods, or whether you think about your model of your disease on which you base your investigations. So then you will see that I go the latter way. Yeah, and I don't need to say the other way is often taken. Now it's the latest is now computational psychiatry. We get into mechanism, but it's the same old model. Yeah, and again, they have the same crisis. They don't yield markers. Next one. So this is clear. Unlike in physical medicine, we're even worse than you dementia guys. Next one. So here we summarize it. This is from a recent paper which will come out in Schizophrenia Bulletin. So it's a twofold. It's a crisis of mechanism. We don't really understand the neuronal and computational mechanism of the psychopathological symptoms. Yes, we have the predictive coding, we have empirical prior, but these are unspecific changes across all disorders. And in schizophrenia, it's even unclear whether the empirical prior is abnormal or not. Yeah, so it's a real lack of specificity, as brilliant as Tristan's model is, and I would really say it's a brilliant thing. So we have no biomarkers here on the left. I'm here. That's also a stagnation in the development of new psychotropic drugs and other therapies. Yeah, so now many psychiatrists just try out some therapy. Yeah, because that's hip, that you get grants, but again, it's blind. So some patients will benefit, some not, and the results are usually immediate. Forget it. And then that's a specific twist I would like to add, as I'm originally from Germany, continental European. It's a crisis of subjectivity. Because what these psychiatric disorders are essentially subjective disorders. It's your experience. So I can hear voices, but okay, I can function very well. But the way I experience them subjectively, that's the key thing. Yeah? So auditory hallucination is a completely unspecific symptom. You have it in dementia often. In progressive stages of dementia, you have auditory hallucination. Yeah? And here, there we are. So same thing here. So that's why we really need to move the mechanism with the subjectivity. And that's the background question for the approach I'm doing. Next one. So what we link is this, what we miss is this triangle between symptoms, brain, and experience. And that's what I call, among others, co-occurrency. That's the key. That's basically now, if you're not interested in the solution, you can go home now and just say, that's what I'm talking about. Next one. Okay, I think next one. So now I show you a little bit what the spatiotemporal approach is. So it has its roots also in philosophy, because I'm also a philosopher. I don't want to go into philosophy now, but I want to tell you one hidden presuppositions in current neuroscience and psychiatry. That's the presupposition of what I call the presupposition of specialness. So the mind and mental features and consciousness and self are something special. There's a special mechanism in the brain added on to the other non-special mechanisms. So here in philosophy, you have the red stuff, it's reflective in phenomenal consciousness, net block axis, phenomenal consciousness. Here I explicated that for the consciousness theory, but it goes the same for the self and all other mental features. And you see here in the consciousness theory, integrated information theory, it's a special mechanism / integration on top of the non-integration in the brain. That's completely stupid. Sorry, I hope there's no IIT proponent here. Yeah, okay, there's a special embodiment, and then we have consciousness. As if the brain is not always embodied. Only the upper part of the iceberg has information integration. Only the upper part is embodied. I beg your pardon. Yeah, and here a higher order thought theory, Lau Rosenthal, global neuronal workspace, and this is a recurrent processing theory by Victor Lamme. Yeah, and then of course here is the brain, and that Friston really says the only model of brain is basically really the Friston theory, and I think also Marcus Reckless somewhat, but it's not well elaborated, his intrinsic model. Yeah, and so this is, and that's non-special. I don't need to tell you, for those who are versed in philosophy, that's basically a continuation of Descartes with the neuroscience. It's a Cartesian neuroscience, it's a dualism. Yeah, so there is something special to the mind, and that's basically Cartesian. Yeah, okay, now the people say, no, Northoff, you cannot say this. We're with the brain, we're no longer mind, but you assume something special in the brain with itself. That's neuronal Cartesian. Next one. Yeah, and that leads to all the problems discussed in current philosophy. I call this here the gap of contingency. It's the explanatory gap problem. It's a hard problem, David Chalmers, and so on and so forth. Yeah, big career, big splash, no output. Sorry. Next one. I will be fast, so okay, good. So next one. I told you. Okay, now so what I do, I say, okay, maybe we should not look for the difference. We look for something similar. What is shared? Again, and this is, it sounds strange and it sounds very metaphysical. No, it's basically what, when you look into the history of science, that's what people do. They look for something similar. Darwin looked for what different species share, what the human shared with the non-human. Thank you. So what humans and non-humans share, I mean, that was from a Christian perspective was a catastrophe. Yeah, Copernicus looked for what the Earth share with the other planets in the universe, not what makes it special, what makes it different. So this is really, and you see in some of my books, I claim for a Copernican term in neuroscience. But this, so I look for the similarity. Next one. So now what is similar? So I always like this quote by Nikola Tesla. So it was an engineer, 19th, 20th century, or from former Yugoslavia, and then he went to New York. And look at this Google. Very interesting guy, very interesting, very idiosyncratic. And there's no, I think there's no coincidence that Tesla, Elon Musk named his cars Tesla. I think they share the innovation, the really creative capacity, which is amazing, but also the idiosyncrasies and the personalities. So that is really, it's amazing. So but he said this beautiful thing, if you want to find the secrets of the universe, think in terms of energy, frequency, vibration. The brain is part of the universe. The mental features are part of the universe. So this is the way you will see, next one, I deconstruct basically the brain. So for me, and it's always a pleasure when I say, okay, the mental thing is nothing special, it's some dynamic, it's some slow time scale, longer time scale. It always puts, you see a smile on my face, because it's simple. You don't need to think about something. Yeah, and that's what we called in this 2020 paper, which has taken up a lot, fortunately, concurrency. So there we explicate that concept, and I say this is what I call spatiotemporal neuroscience. So spatiotemporal neuroscience is not just, okay, there's some topography and dynamics in the brain. No, that topography and dynamics shapes your cognition, shapes your mental states. That's spatiotemporal neuroscience. Yeah, that transition is an explicit, let's say, if you want to say so, brain-mind approach. And you will see, I show this for psychotic disorders. I indicate that for dreams and for mind wandering. We do this for self. We have the temporal spatial theory of consciousness. So it's all, and now I runs this morning, I had a Zoom with somebody in my group for working memory. There's even the temporal envelope timescales for working memory. Of course, makes sense because it's a temporal phenomenon. It's not a special cognitive representation. Next one. So that is shared spatial topography and temporal dynamic. And now you will see that's the way I deconstruct now mental disorders. So I always, and the people who discuss with me, particularly here, the mind one, the meditation, I deconstruct that in terms of spatial topography and temporal dynamic. I infer happily back and forth between phenomenal / experiential and neuronal level. Yeah, we had it with the irreversibility. So I look for dynamic phenomena. Maybe there's something on the experiential side, which is often neglected. But then I can also ask my patients whether they experience it. And whoops, there we are. Next one. So that's basically here, as I said, the indicated that what we developed this temporal spatial theory of consciousness. And first is really we link spontaneous and stimulus-related activity, because that distinction is completely artificial. Anyway, the brain, if it were sitting here, it would smile how stupid we are by using the brain. And second, it's an explicit link between neuronal and phenomenon. Yeah, I will give you later some examples about meditation and dreams as examples of that. Yeah, very short. Next one. I already have that here. Next one. Next one, there must be another one. Yeah, so here, okay, I already give you 2 examples of the temporal spatial theory, how this neuronal phenomenal linkage works. So this is meditation, it's a paper we published end of last year. So basically what we did, that was done here by the first author, Austin Cooper and Bianca Ventura, we investigated naive versus proficient meditators, fMRI. And we looked for the whole brain pattern, and one particular pattern was a topographic pattern where here's a balance between default mode network and control executive network. Usually they stand in an anti-correlation, negative correlation. So if the DNN is high, the CEN is low, and vice versa. And so, and that's basically the same pattern was found in naive meditators. However, now when you go into proficient, so that's basically, in that organization goes basically the cortical midline structures. DNN have been often associated with self-specific, self-related processing. So it's an internally oriented cognition, versus the control executive network is an externally oriented cognition, goal-oriented. So when I now look for you, I recruit more my control executive network, versus if I'm more sort of here in myself and thinking and meandering, how could I make my talk better that people understand me, then it's more internal oriented and cortical midline structures. So in that balance sort of flips, it's neither, so at the beginning it's like this, and in the intermediate stage it's like this, and in the proficient meditators there's no difference anymore. It's neither a positive or negative relationship. So, and then also other data which I don't present here, we also see that the relationship between DNN and visual cortex is much more synchronized. The whole brain is much more unified, synchronized, and less differentiated in its topography. So what does this mean for input encoding? Your input is no longer differentially encoded in the different regions. The input remains as it is from the environmental input, and that's why you probably synchronize with the environment, and that's a basic experience of proficient meditator. You're finally in tune with the environment. You hear this, you have other measures. You can have the surfer who is in synchrony, in tune with the waves. The musician, when you tap the beat to the music, you're in synchrony, your brain synchronizes. And even, I like that particular, we showed in recent papers that if you have a certain temporal structure in your task, 20 to 30 seconds, you have a peak in exactly that frequency range in your power spectrum. Your brain encodes the task periodicity. That's why I always want the temporal structure of tasks. It is often neglected in core, completely neglected. Right? Your brain is adaptive. It's much more clever than we think. So it's amazing. So you're in proficient meditator. So what we said, okay, now you have a dual organization, internally, externally oriented cognition now on the psychological level. And that goes along with a dual organization of your brain, DNN versus CEN. Now in meditation, you lose that dual topography of your brain, and that's exactly what you experience as non-duality. So that's a big thing, that you don't make here all your duality self, other impinges upon your belief, upon your cognition, but in the non-dual state, and it's very well described in the Medi literature, particularly when you go to India, they're crazy about non-duality and non-locality. It's unbelievable. So you really see that duality is no longer there, and that no longer shapes your thoughts, your environment. So you don't make that distinction. Yeah, the basic subjectivity is preserved, but the self-non-self dichotomy is no longer there. The basic subjectivity is preserved, your point of view, as I would say, but I don't want to go into that. So, and also interestingly, you'll see an enlargement of your dynamic repertoire. Your dynamic, Lincoln Kerr Hansen had some nice papers on that with the detrended fluctuation. And you really see an enlargement of your dynamic variability. And why is that important? The more variable your brain, the better you can encode the variable inputs from the environment. And that's so better you can align to the stochastics of this movement. I walk here. If you have a large dynamic repertoire, you can follow me. Yeah, I hope so. And that's also, you better align with the environment, but you process, you encode more inputs, and you process that input in a less differentiated way. So basically, you less manipulate the input. And I think that's very well reflected in many meditative experiences. Next one. So that's an example where how neuronal topography translates into mental topography. Non-dual on the neuronal side, non-dual on the mental side. So that's, you will see, I make a similar case now for mental disorders. So for me, psychiatric disorders are specific space-time disturbances. And as you know, space and time have multiple dimensions. So that's, of course, I can say now there's spatial temporal disturbance, but that doesn't yield anything clinically. I need to specify. And that's what I will show you in the following. So for me, mental disorders as a general statement are space-time disturbance of the brain's inner time and space. Next one. So now I show you, I provide a little bit flesh to the bones. I show you two examples, and the first example is depression is a speed disturbance. Next one. So, as you all know, depression, you're melancholic. The typical, there are different forms of depression I don't want to get. Particularly, I focus here on the retarded form of depression, where you sit in the corner, you can't get up in the morning, you're depressed, you have rumination, everything focused upon yourself, negative mood, you don't move, your perception is, and so on and so forth. So when the working assumption, this is based on many years of studies and phenomenology, experience, and back and forth, and neuroscience, and I will show it's really, for us, it's a speed disturbance. You're too slow. Your brain is too slow, and your psychological functions are also too slow, and your experience also reflected slow. Now, and that's a huge, this is for me basically when I speak of a basic disturbance or generative disturbance, I mean basically like the relationship between glucose and insulin is the generative disturbance for the various diabetes symptoms throughout the body. So now compare that, I always like to make that comparison. So now compare that in mental disorders and in depression, you have affective symptoms, you have cognitive symptoms, you have sensory systems, you have motor symptoms, you have social symptoms, you have mind-wandering problems. You have basically all cognitive functions are changed. Yeah, and they're not as strongly changed, let's say, like in dementia or like in a frontotemporal dementia. It's more sort of a graceful degradation, as some computation with Stephen Krosberg, I think he used the term, as a graceful degradation of a network. Yeah, so it's some sort of subtle, not clear stance, highly inter-individually variable symptom constellation. So for me, it's not a single symptom, it's a co-occurrence. We call this co-occurrence of symptoms. So and how is that possible? So, and I said that in the same way as in diabetes, you have a co-occurrence of symptoms here in the retina, here in the big toe, you have a gangrene, you have symptoms everywhere. Now imagine if you weren't knowing that this is related to insulin glucose, you would say these are all different disorders. Yeah, and different people present, you would not combine them. Yeah, but once you know the basic generative disturbance, the glucose level modulated by the insulin, yeah, makes sense. The glucose goes everywhere and so on and so forth, and there are inter-individual differences. Same here. So that's what I call, so be careful. When I speak of generative or basic disturbance, I do not mean the cause. The causes of diabetes are the causes of the depletion of insulin. There are multiple causes. Could be secondary, or you eat too many sweets, environmental impact. Yeah, very interesting here. I just want to note that. I come back. Yeah, and it can also be highly heritable, type 1 diabetes, and so forth. I don't know much about diabetes, as you see. Okay, next one. I just want to make the analogy. I'm not doing anything special or metaphysical here. Next one. Okay, so now I show you the slowness in different domains, psychological and brain. So here, this is a line of research is visual perception. So we do this motion suppression task, and it's intrinsically a dynamic task because you have basically these little gratings, it's called, they move. And you have to click the button when you can see in which direction it moves. So the task itself is dynamic. And what we modified, this is a standard task, which is very well known to particularly activate V5, middle temporal higher order visual cortex, motion suppression area. So it's very well known. And you can calculate it through some complex psychophysics, which is too high for me. So you can basically, and we constructed that, how they perceive this. So this is a new point what we did. Because from these, basically your reaction time and other parameters, and how fast this move, you can reconstruct how much the gray level of these pixel changes, yeah, compared to the original. And then you can basically reconstruct how they perceive the original. And that's important. So this is what I call subjective reconstruction, because that's what we need in psychiatry. How do people subjectively perceive this thing? Our objective measures are not relevant because you want to see how they perceive this thing. So, and then we also included a fast and a slow version. And what we could see that the depressed process perceives the fast version like the slow version. So now imagine you cannot make a difference between this and between this. What I did first was the same as this. Of course, you become depressed and you become detached because you can't perceive half of the reality. So now I'm switching your attention to this one. Yeah, and then you can reconstruct how much, as I said, the gray level of the pixel changes relative to the original. And what you can see, and you can calculate that in curve, we call this motion distance. And you can see that the difference between the original, which is sort of somewhat static, is much larger in the healthy. So they perceive it much more dynamic than the MDD. So it's more static. And that's exactly, when you ask the people, that's what they tell you. Yeah, so it's no longer they lose in their visual cortex. And when we showed that this is related to decreased power in the faster frequencies in the exactly that area in MT. This is various papers we published. You see this over the last year. Next one. Yeah, this is, for instance, here. So here we did separate experiments. So here we did visual checkerboard stimulation in different frequencies. In 4 different frequencies, you can see this here on the right. We stimulated in 4 to 8 hertz, 1.2 hertz, 0.4, and 0 hertz. Yeah, so it's checkerboard, same stimulus, just different frequencies. So we probe for how the external dynamics of the input modulates activity in particular here, here in the MT area. And this was fMRI. And you can see that in the healthy subjects, you have more higher amplitude, so this GLM modeling in fMRI, higher amplitude in the two faster frequencies. No surprise, because they recruit more neurons, more activity, so you have higher amplitude. The blue ones are the depression, and you can clearly see this. Here the depression are less, and then we grouped the two slow ones and the two fast ones, and you can see a clear difference. The depressed do not process the fast ones in their MT. It's more similar to the slow ones. So then, interestingly, because this is really a task, it has been shown in monkeys and animals and humans, it is really MT, but we also show that other regions, other regions are strongly involved, the anterior cortical midline regions, which are known to be key in depression. So they're also involved. And we can see the same thing. Here, there's no difference how they process the fast and the slow stimuli, even here anterior cortical midline. So that really suggests maybe that's a whole brain thing. And we have another study which where we showed different subjects where we showed the same thing. Next one. So then, next one. So that has therapeutic implications, because you can single out patients who have particular strong visual perception and V5 neuronal differences. So this could be a marker, and I want to use it as such. So that's why we did one study, occipital cortex TMS, which in the field of depression is unheard of because it's everything dorsolateral prefrontal cortex and maybe a little bit frontal. And if you do something else, trust me, they kill you. It's unbelievable because there's a whole mafia and there's money involved and FDA approval, private practices, and blah, blah, blah. Usual American way of doing things. So, and we had very good rates. Yeah, 50, 66 responders. Then we did another study, particularly for motor cortex people, and again, we showed very good efficacy. So, end of the story, probably doesn't matter where you apply the TMS pulse because the brain acts as a global brain. Next one, you don't tell that to the TMS people. Good, so that's basically you show in input regions is too slow on psychological and neuronal levels. That's why I'm so, in the modeling, you see this in some of the model stuff in our recent paper, for input encoding. So I'm interested in simulating different kinds of input constellations and different kinds of state dependencies, how they relate to different inputs. Because that's for me key. For me, these disorders are encoding disorders. So now we did something really interesting, at least from my point of view, thoughts. So what we did, we tried to get into the thought dynamics. So this is a line of research which we're doing, that we say we calculate thoughts in terms of timescales. And more will come out. Next one. So here we did a study where we can see this here. So subjects were in front of the computer, and they were instructed to, when their thought content changed from internal to external thoughts. So external thoughts when I perceive you, environment, internal thoughts about my own self. And then they had to click the button. And here we did it Q-based. You can also do this non-Q-based. And we had 10, 20, 30, and all in between second, where we gave cues, how much it was internally or externally oriented, and we also measured the degree of awareness. How aware are these thoughts? We did this in healthy, depressed MDD, major depressive disorder, and depressed bipolar patients. And the first thing, maybe I show you next one, and after that, next one. Next one. Okay. So now we did, and we reconstructed that in terms of a power spectrum, because you have a time series of change. Yeah. And you have awareness ratings. So the awareness ratings are basically, yeah. And here you can basically calculate, and you can reconstruct that. We did an FFT here, and reconstruct that time series, and you have to do this for quite some time. So this was 15 minutes because you need a number of trials, obviously, because you want to reconstruct this. So here's the frequency, and here is the power. So it's the frequency of your thought change, internal, external thought change, and the power associated with that. So, And you could see here the healthy subjects, they have all frequencies and a fair amount of power. Now look for the MDD patients. No power and not much change. Ask the patients, that's exactly what they experience. I'm drained off, I have no energy, and nothing changes. My thought is the same, ruminating thought, circular thought, you see I indicated. We correlate that with the brooding is a subset of rumination scale and exactly high correlate. Now, in the depressed bipolar, we saw a similar pattern, but not exactly the same. Now you can go back. Click this one. So here, for instance, I show you one main result of that study, that the frequency of the thought was somewhat slower in the MDD than the DUD. So we have the similarities between MDD and depressed bipolar, which of course makes sense, but also some differences. So meaning another possible differential diagnostic test, yeah, which doesn't exist in the literature. Next one, now you can go ahead, next one. So that's about thought. So we're thinking there's one study, of course, now you say do this for emotions. Yeah, so that's something, of course, we still need to do. But there's one study in PNS 2014, Limput et al. From a Dutch group. It's very interesting. They showed indeed that the dynamics before the onset of depression, you have a slowing in your change in your emotions on the psychological level. Typical dynamic system, critical slowing period. Yeah, and that's exactly what you observe. And there's other papers since on that. So now I go more. So I showed you some dynamic and speed on the psychological and partial neuronal level. Now I show you a little bit about the topography. Next one. So I'm a big fan of what is called the global signal in fMRI. So I know that you guys usually often many just regress it out. However, it has a physiological basis, has been shown in monkey studies, combined electrophysiologically, fMRI, Leopold, Shervinik did some fantastic papers there. And it basically says there's an infraslow fluctuations, that's the electrophysiological basis. And what are infraslow fluctuations? They have long cycle durations. They extend over several regions. So global is to be understood in a relative sense. Yeah, so we are a big fan of the global signal. I think there was a no, you're too fast for me and I'm too slow for you. Okay, there we are. That's a discrepancy. Okay, so what we did, so now say, okay, maybe these are, remember what I showed in the meditation, these are global topographic reorganization disorders. Yeah, your topography reorganizes your balances. We had one paper in 2016 in PNS where we showed that the balance between DMN and sensory-motor network is abnormal in bipolar and differential so in mania and depression. Yeah, so here we show you a global signal paper, and we replicated those findings and others too, that they've increased global representation of brain activity in the cortical midline structures and the default mode network. Yeah, and what do I mean by that? So look for climate change. Bad topic, but unfortunately very relevant. You have a global change in the ozone layer, and that is differentially manifest in different parts of the world. Yeah, that's exactly same with the brain. You have global activity shared by all regions of the brain, but manifest to different degrees in different regions of the brain. That's the global signal topography calculated GS score. So in the CM depression, they show significantly higher global signal activity here in the midline regions. And then interesting, the proof of principle, when you apply the global signal regression, then that difference appears. So that really suggests that there's too much global activity representation in this midline region. Everything is focused on that. And the sensory regions, remember the visual cortex, have decreased global signal representation. So basically then, it was a very clever thing done by Andrea Scalabrini, a former postdoc of mine who is now professor in Bergamo. So then we correlated the GS in the default mode network with a non-default. And you see an abnormal correlation. Yeah, versus when you apply in the healthy subjects, you don't see that. Meaning the default mode and unimodal regions are more independent in the healthy subject. But in depression, your unimodal regions are completely enslaved by the default mode. Your perception is enslaved by your ruminations, by your focus on yourself, your negative, your guilt, and everything. That's exactly the clinical reality. Then, this was a small sample, 50 subjects. We did machine learning. We got an accuracy of 90%. With 50 subjects, it's nothing. We have studies with 1,000 and 100, they don't even reach coming close. Next one. So clinical relevance. Next one. Okay, now that's another diagnostic tool which I would like to use, the global signal representation. So here I show you data from, that was a paper by Young et al. 2017 in schizophrenia. You see abnormal conversion of your global signal representation between uni and transmodal regions. Then we showed in bipolar increased global signal representation for, among others, in the motor cortex in mania. That's very interesting because when you see a manic patient, she or he walks around like crazy. So you have increased global activity in the motor cortex that correlates with your psychomotor agitation symptom. Yeah, in depression, we got the hippocampus, you can see that here, and again, makes sense, increased memory recall, autobiographical memory retrieval. Yeah, and next one. Yeah, so, and oh no, just go back. Yeah, and then the findings I showed you before. So you have 3 different patterns of the global signal topography in schizophrenia, in bipolar, in depression. Clinical biomarker, next one. So that's why we like to validate this now in large-scale clinical studies. So, same, I showed you thoughts, I showed you visual perception, I showed you brain, now I show you movements. Next one. So here, this is a paper just came out very end of last year. So you're too fast for me. I'm depressed from your perspective, right? I didn't know that I look like that. Okay. So here we did a visual emotional paradigm. It's a 2x2, fast versus slow, and neutral versus negative stimuli. Because we wanted to interaction between speed of the stimulus and the emotion. So that's what we did. So in particular, and we applied the global signal stuff here. So we did not apply the usual amplitude-based, event-related, blah, blah, blah approach, but we applied the global signal approach. So we presented that in block design, 4 blocks of these 4 conditions, negative fast, negative slow, neutral slow, and fast. Yeah, because for global signal, you need to analyze in block terms. So you need a continuous data set. And maybe somebody some water that's in between I can drink a little bit. Sorry. Yeah. And so what we observed here is that we showed global signal representation here in the different regions, and in depression, during the task, particularly negative fast, they showed decreased global signal representation. So they cannot activate their global signal, particularly in negative fast stimuli. And it was only the global activity component. When we did a GSR, global signal regression, the findings disappeared, as in the other paper. So that tells us the importance of the global activity component. Each region has 2 activity components, a global and a local one. And that can shift. And you see this typical regions, posterior cingulate, anterior midline regions here, anterior midline, posterior cingulate, typical regions, superior temporal gyrus. So insular, typical depression regions. And then we did another analysis. This is a posteriori, just whole brain correlation with psychomotor retardation, because the idea was maybe that correlates with the degree of psychomotor retardation in our scales. And there we are, and we got again, of course, makes perfect sense. We had the precentral gyrus, premotor cortex, inferior frontal gyrus, posterior cingulate cortex, correlating with motor retardation. So now, given these findings, you would like to apply in subjects which show strong psychomotor retardation and global signal decreases in the motor cortex, that's the people who should get motor cortex TMS. And we have one pilot study, which is we're just preparing for submission, where we successfully applied TMS in motor cortex of depression. So here you have direct link of your symptom, potential mechanism, quote unquote, plus a therapeutic indication. Next one. So now you say, okay, how is all that related to your negative emotions? So you want to know something. Then again here, topography. Next one. And I have to make a little detour here. So the self is a big topic in neuroscience. There are probably as many concepts of self as researchers around, and it's a catastrophe. So here we did a large-scale meta-analysis of all task-evoked studies on self, on the body, on the interoception, and also on the typical, perfect, that is very nice. Thank you, appreciate it. Let me just have that. And so here we did large-scale meta-analysis, all task-evoked studies in healthy subjects. And what we observed is sort of, so we looked for various regions involved. I don't go into details here about that. But we sort of observed, based on the data, 3 different layers. So interoceptive regions, typical insula, I don't mention that here, thalamus, other subcortical regions, of course, makes perfect sense. That's all the interoceptive task when you have interoceptive awareness, urogenital, heartbeat, and all that. Then extroceptives, this were the proprioceptive task, mainly Olaf Blanke, the studies. And interestingly, those studies found the temporal parietal junction, you know, all this premotor cortex, anterior medial prefrontal cortex, but also replicated the same region as in the interoceptive. So these were independent set of studies, but these regions that you observed here were replicated here. Yeah, plus additional regions. And then the same, these are the typical mental self-task, like trait adjectives or autobiographical stories. So it's about your cognitive or mental self. Again, you saw, to my delight, of course, all the cortical midline structure, plus the regions from the previous level, independent study. So that hints upon a nested organization, like the Russian dolls. The shape of the smaller one is replicated in the next larger one, and so forth. Yeah, and you have also in China, you have beautiful crystal balls, same thing. These are really beautiful, it's incredible. Yeah, so you have a nested organization. Now, what do you think this nested organization, when some of this balance changes, that's what happens in psychotic disorders. Next one, now you're allowed to click. Okay, perfect. So now we did, so here we did again, it's an fMRI, it's an fMRI approach again with global signal. So we looked for the degree of global activity representation in the, stop. It comes automatically. Yeah, I know this is tricky. I don't know why that is. Okay, some hidden artificial intelligence there. So we basically investigate the degree of global signal representation in these different regions of the different layers of self in healthy and in depression. And this is fMRI. And what we observed, and doing a task, doing an emotional attention task, and you could again see into as okay, exoceptive, and these were trait depression. These were non-acute MDD patients. So this is trait features, it's important. It's non-acute. And what you could see, it's an increase in the exoceptive and also an increase in the mental. No surprise, that goes well with the symptoms. And here we did the same for the different, we plotted, this is the same data plotted here, but according just the sequence, the balance between the 3 different layers, and you see it's really very much different. These 2 layers stand out compared to the interoceptive. So you see already that the global signal representation, remember I present an overall topography of DMN, non-DMN. Now I present you within basically the transmodal regions. I again show you an altered topography with an abnormal increase in the DMN. And that's related to your self stuff. Then we also did an emotional attention task. And the behavioral data of that, I don't want to go into this. This is the multinomial regression analysis. So we had 4 values of the emotional attention task, whether they could attend it or not, positive, negative, and neutral. And you could see that these different layers also modulated the emotional attention task. And so meaning you have an abnormal global signal representation across the 3 layers of self, and that in turn leads to abnormal emotion regulation or dysregulation or emotional attention. So here you see that the self might be on a psychological level a basic disturbance because it's involved in everything. So again, these 3 layers, that's what I want to develop. It's probably, hopefully, a differential diagnostic marker. For instance, in anxiety disorders, you see a decrease there. Okay, so that's difficult. Then I speed up. Okay, I finish the depression in time, and then I, next one. Next one. Next one, you already know this. Next one. Okay, next one. No, go back. There's many more slides coming. Okay, I hope you'll give me a couple of more minutes. Okay, good. So here you can say, yes, but maybe your time changes, your speed change is just a consequence of abnormal cognition. That's the way cognitive people would argue for. And I say, no, even on the psychological level, your abnormal time in the brain constitutes or generates an abnormal time perception of slowness, and that in turn shapes your cognitive function in an abnormal way and / your symptoms. So it's an abnormal dynamic scaffold or envelope for cognitive functions. So, and the people would argue in the psychiatric perspective that the time perspective, time perception, is just a consequence of the depressive symptoms. As I said, I say the other way around. So here we tested this. Pure psychological study, 100 subjects. I know I need to be fast. So we also investigated childhood trauma. Higher incidence in the depressed patients. And we had 2 different mediation models, either time perspective, Zimbardo time perspective interval inventory, either as a moderator or as a dependent variable. So which mediation model hold? This one. This yielded a full mediation, this one not. So if you have a trauma might not lead to depression if your time perspective, your time perception is normal. Yeah. And here, this is the other way around. This yielded a full mediation, no mediation at all. So this really supports for me time perspective. Next one. Okay. And we have another line of research again with my former postdoc in Bergamo, where we have 3 different layers of trauma related to the 3 layers of self. So this goes strongly into psychodynamics. This is Clara Mucci, is a collaborator here, because she, from a purely psychodynamic perspective, distinguished these 3 levels of trauma, but I don't have time. Next one. Good. I hope that's clear, and I hope I could also indicate it has potential biomarker relevance. Next one. So now this I will walk you very quickly through. Temporal imprecision. Next one. Positive, negative symptoms. So the idea is here, this is a temporal imprecision. You're imprecise. Next one. I show you the data and I walk through so fast. Temporal windows are too long. Next one. So here we did also, next one. Stop. We did also the autocorrelation window, and we probe for temporal integration. If you integrate too much, you're temporally imprecise. Yeah. So we probe for temporal integration on the neuronal level, measuring the autocorrelation window. And on the psychological level, by this continuous task is a phase morphing task from Tsakiris originally. Phase morphing task where you have to indicate when it's no longer your face or when it's your face. So it's other self-morphing, and in either direction you go. And that's basically temporal integration, because if you integrate too much, you still see another person's face as your own face. So that's a design because it's temporal integration within the paradigm itself. Next one. Yeah, that's the autocorrelation window. Basically, you measure your time series with itself, the degree to which it correlates in terms of next one. Yeah, so here, next one. We saw that the autocorrelation window is too long in the schizophrenic patients. And that was 2021 published. You see this here, significantly longer. Here, the red ones compared to the blue ones. And this is replicated in a completely independent data set, which was just published a couple of months ago. You again see the autocorrelation window doing the oddball task and in the resting state, too long. So your too long windows, you integrate too much, so become temporally imprecise. Next one. Yeah, I'm temporally imprecise now, I know, but I try to judge. So how is that related to symptoms? So here we were lucky. We could collaborate here with partners in Denmark who developed this. Unfortunately, David is not here, David Martinez. I'm sure he knows this EASE scale for experience of the own self, anomalous self, and that's a qualitative interview. And what we could see is that the relationship between the basic self-disorder and schizophrenia and negative symptoms is mediated by your time scale. So that is beautiful. Because you see your neuron operates in the background and mediates the transition to the symptom. That's exactly what I want. That's why I speak of spatiotemporal psychopathology. Next one. Okay, next one. I probably skipped. Yeah, okay, next one. I make this very short. So if you confuse internal and external reality, then how is that related on the neuronal side? Meaning you may not be able to make a proper distinction between your resting state or pre-stimulus activity and your task-evoked activity. Meaning your external task or input is not properly differentiated from your ongoing activity. So you look at me, but I just don't process that really properly, just integrate it into my ongoing mentation, my inner thought. And of course, then I think you will want to kill me or some strange stuff. Yeah. So, and that's exactly, so here we did a meta-analysis on different EEG studies, mainly, and also fMRI and schizophrenia. Those studies which included both rest or pre-stimulus activity and task-evoked activity. In the analysis, and you will see it's not many studies. This was 2021. The catastrophe, and reviewers asked me, why are you doing this? It's not relevant. It's incredible. Yeah. So, and we showed this, and whether the pre-stimulus measure is high or low, here's the red stuff, is too low or too high, different kinds of EEG measures. In each case, you have decreased pre-stimulus task difference. So that's really your system is in an extreme dynamic state, too high or too low, it doesn't react anymore. Next one. And that's, of course, confusion, internal, external. Next one. So this is a really interesting stuff. Now I have to drink a little bit. I hope that minute you will give me. And then I continue here. So here we look now for temporal imprecision in the millisecond range, in the amplitude, task evoked, and in the phase of the EEG signal. So this here, this was was done by her from Greece. I never can pronounce her name, so Maria is her first name, it's easier for me. So, and she applied this very clever approach. It was an internal initiation paradigm where you, as you click and then you get a tone. And she applied a temporal transfer function. It's a very clever, and what you could see in all these frequencies, EEG obviously, that you could see increased delays in the amplitude by applying this transfer function. Yeah, and she also saw increased intra-subject variability of those delays. So that's the amplitude is more delayed and more unstably delayed in the schizophrenic. And this is millisecond. Yeah. So that's you could find out through the transfer function and again replicated. So then we did for the phase. So in the amplitude, you have some temporal imprecision in the millisecond range. Now in the phase, this is intertrial phase coherence. You have an auditory oddball paradigm, continuous tones. You have to click the button, but you have to click the button only when there's a deviant tone. So it's called an attention paradigm, but for me, it's an external synchronization paradigm where you have to synchronize. And you can see the phase onsets synchronize with the onset of the external stimuli, the alignment. So in what you see intertrial phase coherence in the healthy subject, you see particularly in theta and delta, because that's the rhythm of the intertrial interval of your tones. Nobody is mentioning that. You see that a high phase coherence in the brain. And you see this here as a typical phase circle, high. Now in schizophrenia, you don't see that. The phase can't synchronize. And you see this when you have music therapy with depressed patients, they stand around the schizophrenia and don't know what to do. Yeah, because they cannot synchronize because it's temporally imprecise. See this here, and this is one of the best replicated findings, the decreased phase coherence, and we combine that also with computational modeling to see it's really the phase offsets. And this is diagnostic specific. You don't see this in bipolar nor in depression. We have a paper in Revisional Molecular Psychiatry on that. Next one. I know, I'm almost over. So here, now you say, how is your phase coherence, the millisecond, related to the more longer time scale of the autocorrelation window? So this is, again, now with this here, we could replicate this another data set, replicate the autocorrelation window, could replicate the decreased intertrial phase coherence. Now, how are they linked? In the healthy subject, the black line, they highly correlate. Yeah, meaning if you have shorter autocorrelation window, you have higher intertrial phase coherence because you're more if you have a shorter window, temporal segregation, you're more temporally precise in the phase onset to follow these thoughts and my speech, hopefully. And in the depression, that doesn't exist anymore. Meaning your ACW, your temporal window provides a template for your synchronization here. And that is lost. And the schizophrenic patients are literally lost. And this is millisecond range. Next one. So then you say, where is this coming from? These were all task data. Now show me whether there are some phase inconsistencies in the resting state. How do you measure that? So Stefan Lechner, very clever guy from Austria, he developed a new method, a very small bandpass, 5 to 7 hertz, and he basically calculated the projected cycle time points of the cycle durations of the ongoing cycle duration. And then you can measure how they deviate. So there's spontaneous phase variability, and that spontaneous phase variability is too entropic in the schizophrenic patient. Irregular, imprecise, milliseconds. Yeah, this is really milliseconds. Yeah, so this is really, and you see it's too high entropy here applied in sample entropy on this spontaneous phase variation. Next one. We do this more and more also on behavioral data, second order analysis of the times. Next one. Okay, so then close to the end. How is that manifest in subjective experience? So we developed a spice and time experience scale for schizophrenia, and we also now we have in the loop in our pipeline this time and space experience scale for depression and anxiety, because I want to map this also, again, differential diagnosis. And certain items here, particularly item number 7. So this is a schizophrenic group. This is the non-schizophrenic bipolar affective group, and this is healthy subject. You see, item 7 is almost specific for every patient experience of temporal fragmentation. Yeah, and premonition also here. The premonition is typical item 8. Yeah, so that's also one of the diagnostic layers which can be used. And again, same for time, space, experience, and depression. Next one. So next one. Okay, I probably skipped that one. Even we did some drawing in those guys and see again temporally fragmented. You see temporal fragmentation is everywhere for me. Next one, except in my own brain, of course. There's no time at all. So temporal imprecision. Next one. Clear. I hope it's in the timing. I think it's a Anne-Marie Wolf postdoc of mine, who's now professor in Queens. Had this very nice heading. Next one, and that also goes with some old phenomenology in schizophrenia. Minkowski, very clever guy, psychiatrist. He described it as a loss of vital contact with reality. Now, you see, I added the dynamic, and that's a temporal imprecision. If you cannot synchronize, cannot encode the inputs in a millisecond range, you're confused. And that carried forth to the rest of your brain. Next one. So for me, it's an encoding deficit. Okay, next one. So here, I show you that basically, I hope I made it clear, it's common currency, or we missed an M there. Common currency of brain and symptoms. We have different lines which you can diagnose. Next one. Here we have subjective experience. which I would like to include. Then you have these different markers, which I showed you, spatial measures, temporal measures, which I think yield strong support that there might be a sort of, what you say, diagnosis of syndrome specificity, and that really awaits larger clinical trials. Next one. Next one. Next one. I indicated that it has major implications for therapy, particularly in depression. I showed you the TMS stuff, in visual cortex, motor cortex, and also we have currently an ongoing study in anxiety where we use a breathing protocol. And why breathing? Because anxiety, fast and irregular breathing, thoughts are racing like crazy. So they have temporal irregularity, and that yields temporal uncertainty. And if there's uncertainty too much, you become afraid. So there's a lot of some computational study for temporal uncertainty, but it's not really associated with the dynamic or temporal uncertainty. That's the way I add. So it's the legs to what they investigate on the cognitive level. So while breathing, because in breathing, long, if you breathe very slow, you have long phase cycles. They're good for integrating your different thoughts and your different stimuli and calm you down. And we see dramatic effects. So this is a tentative, this is 10 subjects. You see, this is a back anxiety scale, and this is a mind wandering scale, spontaneous mind wandering. You see a reduction. This is after 3 weeks, after 6 weeks. You see a huge reduction in T1, T2, and important in all subjects. All of the 10 single subjects showed a back anxiety reduction. That's unheard of in psychiatry, okay? It's pilot data, it's early, but that's again, one of the tools besides the TMS for a large scale clinical trial. And we also individualize the breathing frequency. We let them come, we let them breathe on different frequency ranges from, let's say, breathing rates from 5 to 12 or 14, and see which, and then we have various Likert scale, and which one is the most comfortable breathing rate for them. So we individualize that, and we later want to do this with the EEG and also with the computational modeling. Next one. Yeah, and I come to the end. Last talk, I probably overstepped my 10 minutes. Yeah, and if you want to read, this is about a lot of psychiatric case histories. This is the most recent one. Both books are very short and I think well understandable. Thank you very much.
Thank you so much. Your very inspiring talk. We will have a time for overall discussion. So I think that we can start with our next speaker, that is Claudia, and we will have, I have a plenty of questions for you, but we will have a full time for discussion at the end of the presenters. Thank you so much.
¿Ahí? Sí, se puede caer. Gracias. Gracias. ¿Puedes presentar? Esta presentación acá. Sí, por fin. Y esta acá la... No te preocupes, yo la voy cambiando. Muchas gracias. La presentación ahora vamos a cambiar a español y también vamos a cambiar un poco. Ay, gracias. ¿Ahora sí me veo ella?
You were not that lucky, George. I'm sorry. You were not that lucky, you know.
Y la voy a hacer un poco más básica, básica en el sentido biológico. Y voy a intentar hablar un poco, me gustó mucho preparar esta presentación, gracias Agustín, estudié bastante y voy a intentar hablar de los TASI, salud mental y salud cerebral. Puedo ponerme. Gracias. Este es el outline. Primero voy a definir a los TASI. Voy a hablar un poquito de la historia súper rápido por el tiempo de la presentación. Voy a hablar un poco de cómo se mide la alostasis ahora en este minuto. Voy a hablar un poquito de una de las proteínas más involucradas en esta, como en esta forma de alostasis, que es el cortisol. Voy a hablar un poco también del índice de alostasis, de la carga alostática, y cómo se mide y qué se ha descrito en términos de armonización. Y voy a hablar un poco también de los distintos papers relacionados con alostasis, salud cerebral y salud mental. Entonces acá tenemos un poco la definición de alostasis, de carga alostática. Nosotros sabemos que alostasis finalmente va a ser la mantención de la estabilidad a través del cambio. Y va a ser, esta alostasis es un proceso continuo y es un proceso también de balance energético y una mantención de nuestro cuerpo a anticipados estresores. Entonces, finalmente la alostasis se refiere a esta mantención, a esta estabilidad, a distintos tipos de estresores que les voy a mostrar en toda la presentación. Pueden ser internos, externos, como Agustín habló, el exposoma, etcétera. Y bueno, cuando pasa el cuerpo por las distintas, desde las moléculas, células, cerebros, etcétera, cuando hay una sobrecarga de estrés, ahí se produce la carga alostática. Y la carga alostática se puede medir de diferentes formas, y en esta presentación yo les voy a mostrar la parte más biológica de cómo medir la carga alostática. Entonces, un poquito de la historia. Sterling, y no sé cómo se pronuncia, Eyer, ¿sí? Ellos estuvieron estudiando el término finalmente alostasis, o ellos describieron el término alostasis porque no les acomodaba la parte de homeostasis. Y homeostasis finalmente es una mantención, pero en un subcompartimiento. Y ellos querían ver qué pasaba desde el medio ambiente o distintos tipos de estresores, y por eso adjudicaron o crearon este término de alostasis. Y esto viene hace muchos años, desde 1988, 30 años aproximadamente, viene el concepto de alostasis, no es reciente. Y luego ya después de eso, después de la definición per se de qué significa alostasis, McEwen y Stellar propusieron esta idea de que hay un estrés crónico y que va a gatillar finalmente cambios biológicos, cambios en la célula, cambios en nuestro organismo, y que esos cambios pueden ser medidos clínicamente a través de distintos tipos biomarcadores que son moléculas o que son proteínas que las podemos medir físicamente, o sea, clínicamente. Y acá está el paper y acá están todas las definiciones. Ahora bien, luego de eso, McEwen y Seaman, que estuvieron trabajando juntos, McEwen ya murió, me parece que murió hace como 8 años, 10 años, y como anécdota, en general en casi todos los papers de alostasis que por lo menos están en esta presentación y que leí, le dan un agradecimiento a McEwen porque él fue el que creó este concepto, o lo definió propiamente tal en relación a los distintos tipos de predictores. Entonces vamos a hablar de primero que hay unos predictores primarios, que estos son los que van a dar la respuesta inmediata y están relacionados con el sistema neuroendocrino, ¿ya? Y estos tipos de hormonas, y las más como estudiadas, es cortisol, DHEA, epinefrina, etcétera, hartos tipos de endorfina. Y luego de esto, ¿qué es lo que pasa? Un cambio biológico a través de estos predictores primarios, hay un outcome secundario y terciario que tiene que ver con los otros sistemas, el sistema cardiovascular, el sistema el sistema endocrino es el primario, secundario, cardiovascular, metabólico, y también, ahora último, inmunológico. Y todos estos, obviamente, van a tener diferentes outcomes relacionando distintos tipos de enfermedades mentales, como se habló anteriormente, depresión, ansiedad, pero también enfermedades de salud cerebral, o relacionadas, o con esta, después voy a definir salud cerebral, o enfermedades que están relacionadas con la neurodegeneración, como la enfermedad de Alzheimer, la demencia frontotemporal, como otras. Y como ya dije, finalmente la carga alostática se va a estar dada a través de distintos ejes medioambientales o internos, y finalmente se va a gatillar los distintos tipos de enfermedades mentales o enfermedades de salud cerebral. Entonces acá en esta diapo les quiero mostrar el número total. Esta es una revisión sistemática en relación a los distintos papers, si es que buscamos solo la palabra allostatic load en PubMed, y esta es la curva, ha ido en crecimiento el estudio de carga alostática en los distintos años, y eso. Hicimos una revisión sistemática en los diferentes países, pero de Latinoamérica, y qué es lo que hay, y en este minuto, en relación a carga alostática y los diferentes países latinoamericanos, solo hay 15 publicaciones. A lo mejor hay que buscar un poquito más profundo en relación a la palabra clave de la búsqueda, pero ahora pusimos allostatic load como búsqueda. A lo mejor si ponemos, por ejemplo, algún tipo de citoquina, algún tipo de molécula que está relacionada con el allostatic load, podemos encontrar un poco más. ¿Por qué? Porque esto recién se está conjugando y recién se está viendo las distintas moléculas que podrían estar involucradas en relación al allostatic load, o también determinantes medioambientales o determinantes internos de nuestro organismo, o también la epigenética, etcétera. Ahora les voy a dar un par de ejemplos. Ahora bien, ahora les quiero contar un poco de cómo podemos medir la carga alostática, y me encontré con esta revisión sistemática de revisiones sistemáticas. Este paper me encantó mucho porque, bueno, no está enfocado específicamente a la parte molecular, sino más bien a la parte medioambiental y cómo en donde uno vive puede afectar la carga alostática, pero acá lo importante es que ellos hicieron esta revisión sistemática entre 1995 y el 2020 y encontraron 238 estudios, pero hicieron la depuración y solo 18 reviews quedaron acá, diferentes tipos de review relacionando los distintos biomarcadores con la carga alostática, y acá ellos describieron en específico que hay 10 biomarcadores que son frecuentemente usados como carga alostática. Y ahora último, además de esos 10 biomarcadores que van a ser estos como outcome primarios, como les dije anteriormente, la parte como neuroendocrina, después la cardiovascular, metabólica e inmunológica, se adhirió uno que es cardiovascular, que es la masa, ¿cómo se traduce? El índice de masa corporal, y también la proteína C reactiva, que es una proteína inmunoinflamatoria. Acá no les voy a mostrar todo, pero en específico se los dejo porque acá en negrito están los nuevos, los más utilizados ahora, y violeta están los otros que se describen en los distintos papers con el porcentaje. Por ejemplo, acá están los mediadores primarios en respuesta a este sistema neuroendocrino, están los secundarios, los más utilizados, los cardiovasculares, inmunes y metabólicos, y acá están todos los tipos de biomarcadores que se pueden utilizar ahora para medir la carga alostática, y los que se han adherido, como les dije, están en negrita. Y los distintos porcentajes de cada uno de ellos en esta revisión sistemática de revisiones sistemáticas relacionadas con allostatic load. Acá es lo mismo, esta es otra revisión sistemática, pero solo de distintos papers relacionando el allostatic load de la parte biológica o celular y la carga alostática, y indican lo mismo. O sea, finalmente hay estos como mediadores primarios que son los del sistema neuroendocrino, y luego del sistema cardiovascular, y el sistema metabólico, y también el sistema inmunológico. Ahora último, se adhirió muchas proteínas del sistema inmunológico porque también se hace un balance, un índice de eso, y voy a hablar un poquito en la última parte de mi presentación. Ahora bien, les quiero destacar una de las hormonas que se ha estudiado mucho con estrés, porque es la más rápida. Hay distintos tipos de cortisol, uno agudo, uno crónico, y en relación a esto es la parte básica. Está en el cerebro dos partes importantes, que es el hipotálamo y la hipófisis. o sea, sí, la hipófisis, y esto tiene una consecuencia, una liberación de distintos tipos de hormonas y después se van a las glándulas adrenales que están debajo del riñón y esta secreta finalmente la hormona al cortisol y hay un feedback negativo. Nosotros también sabemos que los niveles de cortisol en el cuerpo pueden causar distintos tipos de efectos. Por ejemplo, uno es la resistencia a la insulina, que puede conducir a diabetes o otros desórdenes metabólicos. Podemos tener esta ganancia de peso, hay una supresión del sistema inmune y estamos propensos a los distintos tipos de infecciones. Hay una alta presión sanguínea y que obviamente va a aumentar el riesgo de estos ataques cardíacos o stroke. Hay, ¿cómo se llama? Mood disturbances. Trastornos del ánimo y como ansiedad y depresión. O sea, todo esto es lo que hace el cortisol y también aumenta niveles de glucosa, etcétera. Y para hablar un poquito de lo que pasa con lo que pasa con la insulina o la mala señalización de la insulina a través de esta carga alostática y también en la enfermedad de Alzheimer, nosotros sabemos que están estos receptores finalmente, hay distintos receptores de insulina en el cerebro, en nuestro organismo, y estos receptores de insulina, una vez que se gatilla los niveles altos de glucosa, también se gatilla la liberación de insulina para bajar los niveles de glucosa, pero acá, en estos receptores, hay una señalización interna en donde tiene que ver específicamente el crecimiento de las neuritas. Esto lo estoy comentando porque para ver la relación que puede haber entre los niveles los distintos niveles de insulina o la mala señalización de la insulina en la enfermedad de Alzheimer, pero también relacionándolo con la carga alostática. Porque la carga alostática, podemos pensar en que la carga alostática va a aumentar finalmente los niveles de cortisol y estos niveles de cortisol va a hacer la mala señalización de la insulina y va a llevar a la enfermedad de Alzheimer. Entonces acá tenemos las distintas como partes en específico que hace celularmente la insulina y uno es el crecimiento de la neurita, la otra la sobrevida de la neurita, la liberación de distintos tipos de catecolamina, distintos tipos de amina, liberaciones de distintos tipos de neurotransmisores y el uptake o la internación de la glucosa y el balance de la glucosa internamente en la célula. Entonces, si hay un desbalance en esta señalización de la insulina, va a haber un riesgo de desarrollar la patología, porque la patología también tendría que ver en específico con la hemostasis de la célula o de la neurona. Entonces, acá hay distintos papers en donde muestran en específico que los distintos niveles de cortisol podrían estar asociados con el riesgo del Alzheimer. Entonces acá tenemos que los niveles de cortisol elevados pueden incrementar los niveles el riesgo de desarrollar la demencia. Y esto está asociado porque hay una contribución entre estos niveles de cortisol, glucosa y la toxicidad que puede tener el péptido beta y el péptido tau. O sea, y la proteína tau. Y también el estrés oxidativo. Hay una alteración con estos niveles elevados de cortisol. Se sabe que hay una alteración en el eje hipotálamo-pituitaria adrenal. Y también, obviamente, hay un aumento del factor de riesgo para la demencia o para distintos tipos de demencia y también para el Alzheimer. Los niveles elevados de cortisol también se han correlacionado no tan solo con las demencias, sino también con un paso previo a la demencia, que es el déficit cognitivo o la severidad de este déficit cognitivo. También se ha demostrado una correlación positiva entre la cantidad de cortisol que podemos encontrar en el líquido cefalorraquídeo y la enfermedad de Alzheimer, diferenciando este déficit cognitivo con la enfermedad de Alzheimer. Y también sabemos que el cortisol, elevados niveles de cortisol pueden inducir estos cambios cerebrales y también disminuciones en las distintas zonas relacionadas con memoria y trabajo. No sé qué pasa. Ahí está. Ahora les voy a comentar un poco de cómo voy a medir, o cómo voy a medir, cómo se mide el índice alostático, y se habla acá del índice de la carga alostática, y consiste obviamente en la representación de todos los biomarcadores que se usan o que se utilizan para medir la carga alostática, dependiendo del estudio y dependiendo también obviamente de la plata o del sistema que se quiere medir, pero en general son estos 4 sistemas, como les dije anteriormente. Primero está el neuroendocrino y después los secundarios, que son los cardiovasculares, el metabólico y el inmunológico. Y acá en esta revisión sistemática se estudiaron distintos tipos de estudios, y acá lo que les quiero mostrar que hay distintas formas de poder medir la carga alostática o hacer este índice de carga alostática, y hay distintos tipos de variables. Podemos tomar una variable continua, porque finalmente son niveles de citoquinas o niveles de moléculas que están relacionadas con esta carga alostática, y, o hacer una variable dicotómica. Ahora bien, como último, voy a mostrar diferentes tipos de papers o revisiones sistemáticas relacionando la salud cerebral y la salud mental, definiendo o haciendo una distinción en específico, que la salud mental se refiere a algo emocional, y estas condiciones están relacionadas, como dijo anteriormente Georg, están relacionadas con ansiedad y depresión. En cambio, la salud cerebral es el buen mantenimiento de nuestro cerebro, y si no hay un buen mantenimiento de nuestro cerebro, o esta mantención, puede haber distintos tipos de enfermedades, por ejemplo, enfermedades neurodegenerativas. Entonces, la salud cerebral se va a referir finalmente a la mantención a través de nuestra vida o etapas de vida. Entonces, acá les voy a ir mostrando un poco qué es lo que pasa cuando hago una búsqueda de mental health, allostatic load. Hay 275 papers, pero si hacemos una búsqueda en específico de allostatic load y mental health en PubMed, no hay nada. Y si es que ponemos Alzheimer y allostatic load, sí hay. Entonces las búsquedas tienen que ser un poco más exhaustivas en términos de ver en específico los distintos biomarcadores. Acá, como comentó Agustín al principio, hay distintos tipos. Esto es un concepto nuevo, el exposoma. Es cómo el medio ambiente puede afectar internamente y derivar a distintos tipos de enfermedades mentales o de salud cerebral, etc. Hay factores internos, hay factores externos, y se los dejo acá porque ya me quedan poquitos minutos. Y esto es uno de los estudios relacionando, porque hay más estudios relacionados con mental health. Y este es uno de los estudios en donde ven el impacto del trauma en la niñez en relación a la carga alostática medida a través de biomarcadores. En esta tabla está cómo se mide el trauma en la niñez, las distintas categorías, en un estudio prospectivo, y esta es la tabla en donde miden los distintos tipos de biomarcadores y hacen una correlación, y ellos dicen finalmente que los primeros años de vida o los traumas son cruciales para el desarrollo o para distintos tipos de patologías mentales. En este paper también hacen una distinción en que hay que medir o hay que buscar en específico cómo se miden estos biomarcadores o la carga alostática en adolescentes, porque es completamente distinto a adultos. Y acá hablan de que los biomarcadores en adolescentes solo deberían ser 3, porque hicieron una revisión sistemática de todos los papers o todos los estudios haciendo biomarcadores o estudiando biomarcadores en población joven. Acá también es otro paper correlacionando enfermedad cardíaca o coronaria y síntomas de depresión y carga alostática, y ven una correlación específica, o sea, la enfermedad coronaria o de corazón finalmente, o el riesgo de padecer esta enfermedad está asociada a síntomas depresivos, y también está asociada a la carga alostática en adultos africano-americanos. Y acá, yo creo que esta es la última, es otro revisión. ¿Cuál es la relación entre allostatic load y las distintas alteraciones en el cerebro o las disminuciones en las distintas áreas del cerebro? Y ven las distintas correlaciones con estos biomarcadores en específico. Y esta es la última diapo, creo, sí. En esta diapo, independiente de que se hable un poco de esta desregulación en la señalización de la insulina, es muy bueno porque durante nuestro envejecimiento tenemos carga alostática y está correlacionada con los distintos factores sociales, los estilos de vida, los factores biológicos, etcétera, pero si nosotros podemos intervenir esos factores en alguno de los puntos, podemos disminuir la carga alostática y podemos disminuir finalmente algunas enfermedades asociadas a salud cerebral y salud mental. Entonces acá hay un mensaje a la casa que se necesitan específicos armonizaciones o estrategias de armonización y la generación de una línea de trabajo para medir la carga alostática, porque no todos o los distintos tipos de biomarcadores son distintos. Acá no sabemos nada en Latinoamérica en relación a esta carga alostática o cómo se mide o cómo la podríamos armonizar o cómo la podríamos medir. Eso es lo que se tiene que hacer ahora y también enfocarse en que si es que estos factores los podemos medir, podemos intentar tratarlo o podemos disminuir, por ejemplo, inflamación o distintos tipos de biomarcadores en la parte celular. Eso. Muchísimas gracias.
Muchísimas gracias, Clau. Excelente presentación. Gracias por apegarse al tiempo. Le pido a los dos speakers que por favor se apeguen al tiempo porque la idea es que podamos hacer un debate y discutir todos juntos en inglés y en español. Entonces, dejen para la discusión cualquier tópico que requiera mucho tiempo, así lo podemos conversar y podemos salvar la mente de la audiencia con tantas presentaciones. Mientras termina Coti, aprovecho para decirle, vamos a... ¿El café se puede traer acá para el debate? ¿Se puede entrar a la sala o tiene que ser afuera? Decirlo en voz alta si te haces cargo de la decisión. Bien. ¿No se puede traer? Preguntemos. Sería bueno traer el café aquí y discutir todos acá.
Ya. Yo voy a tener que hablar en 2 porque me acabo de enterar de que eran 15 minutos y no 25. Me había quedado con el plan antiguo, pero lo logro. Entonces, lo que yo voy a tratar de hablarles es un poco de cómo el mindfulness o la meditación mindfulness puede ayudarnos o contribuir al brain health. Lo hago en español, ¿verdad? Mejor, ya. Entonces, bueno, la Clau definió un poquitito lo que era el brain health, pero básicamente se puede definir como un proceso dinámico y multidimensional que ocurre a lo largo del transcurso de la vida y que incorpora todos los procesos underlying, los procesos que subyacen la cognición, la emoción en el cerebro. Y el brain health está influenciado por factores eco-biopsicológicos y sociales que al final determinan si es que va a haber una buena calidad de vida o una buena calidad de vida. Y lo importante es que el brain health se puede medir tanto objetivamente como también tiene un continuo de experiencia asociado a este. Por el otro lado están las demencias, que son una colección de deterioro cerebral y que ocurren generalmente la mayoría de las veces sobre los 65 años y que tienen una condición preclínica bastante alta y estas condiciones hay factores de riesgo que te hacen más propenso a tener estas condiciones, pero también tenemos factores protectivos y la buena noticia es que acá en Latinoamérica hasta un 40% de los casos se podrían modificar modificando estos factores protectivos y de riesgo. Entonces, estos son los factores de riesgo que hay que evitar. Te apuesto que todos al menos tienen uno de ellos. Y estos son los que queremos conseguir para nosotros para cargar nuestro balance alostático hacia una mejor salud cerebral. Y estos son pertinentes, cada uno de estos son pertinentes y modificables más agudamente en distintos transcursos de la vida, de la etapa de la vida. Y uno de un factor que es muy importante y que es un factor protectivo es la reserva cognitiva, que es básicamente un concepto que trata de acuñar las diferencias interindividuales de la susceptibilidad que tienen las personas a tener una enfermedad neurodegenerativa o no. ¿Ya? Y básicamente es como la individualidad, o trata de dar cuenta de la individualidad que hay en cada persona, entre los síntomas clínicos que presentan y su deterioro cerebral, básicamente. Y lo otro que es interesante de este concepto es que toma el impacto de los estilos de vida en la psicopatología cerebral. Y aquí es cuando entra la meditación mindfulness como un aportante, bueno, junto con todos los estilos de vida, o todo lo que se llama lifestyle medicine, que básicamente son alimentación, deporte, y meditación es una de ellas. Y entonces, ¿qué es la meditación? Básicamente es una familia de estrategias de regulación emocional y atencional que están diseñadas para alcanzar un balance emocional y bienestar. Y desde el punto de vista, desde la primera persona, desde el individuo, la meditación es una forma, una técnica de aprender a relacionarse con la propia vida mental, ¿ya? Dentro de ellas, la más conocida en Occidente es la meditación mindfulness, que es tanto una práctica como un estado, que tiene que ver con el poner atención al momento presente y de la experiencia que se está unfolding frente a nosotros, sin juicios ni con interés y con curiosidad y aceptación. Entonces acá un poco para seguir lo que estaba hablando nuestro primer speaker sobre la temporalidad, esto es realmente centrado en el momento presente y es una de las cosas críticas que tiene, de cómo ayuda a la salud mental. Entonces, el mindfulness llegó principalmente al occidente para aplacar los efectos de muchos padecimientos de la salud mental modernas, como son el estrés, la depresión y la ansiedad, pero sobre todo se hizo muy famoso por sus efectos que tenía sobre la mente-cuerpo en relación al estrés, ya que como todos sabemos tenemos un hardware evolutivo que nos permitía ser emocionalmente muy eficientes para estrés agudo, pero luego cuando cambió las dinámicas de nuestras relaciones sociales, etcétera, se empezó estos mismos sistemas para enfrentar estrés agudo empezaron a sobrecargarse y generar los patrones de estrés crónico. Y entonces los patrones de estrés crónico se generan, obviamente es algo multifactorial, pero uno de los elementos muy importantes tiene que ver con los contenidos mentales que tienen las personas y cómo se relacionan con ellos constantemente. Entonces acá hay una cita de John Milton, que es de Paradise Lost, que dice que la mente en su propio lugar puede ser del cielo un infierno y del infierno un cielo. O sea, uno puede estar en un lugar muy idílico, pero estar con una mente muy atormentada y estar pasándolo mal y tener el cortisol muy alto, o puede estar en un lugar bastante conflictivo y estar en una cierta paz mental que va a tener además como el profile inflamatorio del cuerpo bajo, si es que se quiere. Y eso depende de cómo nos relacionamos con nuestro espacio mental. Entonces, básicamente lo que se hace en una primera etapa de la meditación en atención focalizada es que yo mantengo mi atención en la respiración y ahí tengo ciertas redes y lugares del cerebro que se encargan de sostener esa atención en ese lugar de manera sostenida, y luego espontáneamente me voy a distraer y ahí se prenden, se activan varias partes del cerebro, incluyendo la red por defecto, que ya más o menos todos conocemos, y estamos en esa divagación mental que por lo general es autocentrada, y tenemos un momento de darnos cuenta de que nos hemos distraído, donde tenemos una activación de la ínsula, que es esta parte del cerebro que es es encargada de censarse a sí mismo y la corteza cingulada anterior. Y entonces nos damos cuenta que nos hemos distraído y luego entonces tenemos redes parietofrontales que se encargan de llevar nuestra atención nuevamente al objeto elegido, que en este caso era la respiración, y se sueltan las parietales y queda frontal tomando la atención sostenida. Entonces este ciclo se repite una y otra vez. Básicamente cada vez que nos distraemos generamos este ciclo y esta activación secuencial de estas redes neuronales. Entonces hacer esto una y otra vez, al final lo que hace es que nos entrena a poder mantener nuestra atención en lo que queremos tenerla y ser menos distráctiles. También entrenamos nuestra mente y cerebro a estar más atento o darnos más cuenta de cuáles son nuestros patrones habituales de pensamiento, ya que empezamos a encontrarnos con ciertas temáticas recurrentes dentro de nuestro contenido mental. Y además entrenamos nuestras mente y cerebro a darnos cuenta también de cómo está nuestro cuerpo y cómo están nuestros estados emocionales, ya que nos empezamos a dar más cuenta de nuestro cuerpo. Y importantemente, también nos entrenamos a darnos cuenta de que nuestros pensamientos son solo pensamientos y no representan tal cual la realidad. Y esto es lo que se llama el realismo subjetivo, que va un poco también a lo que hablaban en la primera charla, de cómo nosotros percibimos nuestro ambiente subjetivo va a determinar demasiado en cómo vamos a interactuar con el mundo y también nuestro loop mente-cuerpo, nuestras señalizaciones mente-cuerpo. Y este es el tema específico al cual yo me dedico a investigar. Entonces, presumiblemente a través de mecanismos de plasticidad cerebral, etcétera, vamos a manejar mejor nuestras emociones, cambiar nuestros hábitos mentales negativos y desarrollar cualidades mentales más positivas. Se ha visto que la meditación, bueno, hay muchas intervenciones basadas en mindfulness para distintas cosas, y hay varios estudios de su eficiencia, que no es peor que muchos psicofármacos para, por ejemplo, este es un estudio donde el Mindfulness-Based Cognitive Therapy es equivalente a los antidepresivos para evitar la recaída en depresión. Durante las depresiones, por lo general, una persona que tiene presión mayor tiene mucha probabilidad de tener depresión luego en el tiempo, y entonces muchas veces se deja con fármacos para no evitar recaídas, y entonces acá lo que se hace es que en ese tiempo de mantenimiento se aplica esta terapia cognitiva basada en mindfulness para evitar que esa caiga, y es igual que el antidepresivo y sin los efectos secundarios de los antidepresivos como son anedonia y bueno, otras cosas. También un paper nuevo que salió en enero de este año, se vio que no era menor que citalopram para cuadros de ansiedad generalizada, ¿ya? Entonces, los Mindfulness-Based Stress Reduction son no peores que citalopram para los anxiety disorders. Entonces se ha visto, en resumen, les voy a mostrar igual un estudio, pero básicamente que la meditación reduce el estrés, la ansiedad y la depresión por los mecanismos que antes les mostré de cómo se relaciona uno con su espacio mental. Ya les voy a mostrar un ejemplo un poquito más en detalle. Y eso también produce, junto con la reducción de estrés y otros patrones respiratorios que se van gestionando durante la práctica, reduce los riesgos cardiovasculares, reduce los desórdenes de sueño, incluyendo la insomnia, lo cual tener una buena higiene de sueño también sabemos que es un efecto protectivo para desarrollar cualquier tipo de enfermedad o deterioro de salud mental. Se han visto estudios que se reducen ciertos parámetros genéticos y algunas moléculas y marcadores de inflamación, como son algunas citoquinas proinflamatorias. También, obviamente, se ha visto que hay efecto en el cerebro, tanto en su estructura como en el funcionamiento, a través de estudios de conectividad funcional y estructural. En general, aumenta la cognición, principalmente la atención y la memoria, pero también la mayoría de los hallazgos que están ligados a estudios clínicos tiene que ver con regulación emocional. Además, reduce los sentimientos de sentirse solo y de sentirse excluido. Esto es a través de de una cierta forma de ver el mundo que se va adquiriendo cuando uno entiende que uno no es solo uno y que sus pensamientos no son toda la realidad, etcétera, pero también hay prácticas que son relacionales, que están hechas para incentivar la conexión con los demás. Y aumenta la actividad de telomerasa y otros marcadores celulares que podemos hablar más adelante. Entonces, básicamente lo que hace es que disminuye colesterol, hipertensión, estrés, inflamación, etcétera, y aumenta oxigenación en el oxígeno, etcétera, etcétera. ¿Ya? ¿Y esto cómo lo hace? Bueno, yo les voy a mostrar un solo ejemplo porque el más cercano, que es una investigación que hice yo, es que yo les modificaba a través de una instrucción mindful el realismo subjetivo de algo, diciéndole, mira, ahora ves a ver este queque que imagínate que es completamente real y está frente a ti y estás como a punto de comértelo. Y ese era como alto subjective realism, o cuando una persona depresiva está en yo soy malo, yo soy tonto, yo no sirvo, etcétera, etcétera, podría ser un equivalente a esta autoinmersión. O, por el contrario, la instrucción mindful era, date cuenta que vas a tener un montón de pensamientos sobre este queque y deseos de comerlo y todo, y considera esto que son simplemente eventos mentales que pasan y se van, ¿ya? Y solamente manipular esta instrucción hacía que las personas que inicialmente todos tenemos aproximamos más rápido lo que nos gusta y lo alejamos más lento, que se llama approach bias. Y entonces lo que en un estado de inmersión generamos esta aproximación automática, en una condición mindful ese bias de aproximación automática ya no estaba. Y además esto también hizo que cuando tomamos volúmenes de saliva, las personas salivaban en la condición de inmersión y no salivaban en la condición de mindful, lo que quiere decir que también medimos alfa-amilasa, que es la primera enzima que se secreta en la respuesta cefálica para diluir el almidón, aunque también es un marcador de activación simpática, pero era para ver en el fondo cómo el contenido mental se traducía en el cuerpo de una manera consecuente al contenido del pensamiento. Entonces, lo que vimos acá es que básicamente solamente cambiar la instrucción de cómo se mira esto de acuerdo a su contenido de realidad, cambia el patrón de conducta automática, que es preconsciente, que son estas que miden estas tareas implícitas de approach a voice, salivación, y él estaba comentando a Georg el otro día que también ahora estamos a punto de publicar que el encoding de las imágenes en el subjective realism se puede diferenciar las preferencias de comida de las personas, y durante mindful no se pueden diferenciar en el cerebro, ya que de alguna manera esos ítems de comida no son almacenados como tal, sino que son almacenados como solo pensamiento. Estoy muy pasadísima. Bueno, estos son los modelos por los cuales, o estos son los mecanismos por los cuales se produce esta regulación y las áreas del cerebro que se han descubierto. Y tal vez mostrarles que, no me voy a mostrar lo de aging para que después me lo pregunten, pero solo decirles que con todo lo que les mostré, básicamente la meditación lo que hace es que aumenta los factores protectivos y disminuye los factores de riesgo, y que eso lo puede hacer en el transcurso de todos los factores que les dije que están a través del tiempo, donde básicamente, claro, ahora la mayoría de nosotros estamos en midlife, y entonces estamos más en una como de prevención y preparación para el aging, pero se ha visto que que cuando la enfermedad empieza a avanzar o el deterioro cognitivo empieza a avanzar, hay toda una parte que tiene que ver con la psicoafectividad de las depresiones, etcétera, etcétera, que si bien cuando ya se desató la enfermedad de alguna manera no te ataja el deterioro cognitivo, sí ataja todos los problemas como de depresión y de salud mental asociados a padecer las enfermedades degenerativas. Así que nada, esa es mi presentación. Muchas gracias.
Muy buena presentación, Constanza, mil gracias, perdón por el crash, pero de nuevo, la idea es que después nos sentemos a conversar, somos poquitos, entonces podemos hacer una buena discusión. Mario, por favor.
Listo. Listo, muchas gracias. Bueno, muchas gracias, Agustín, por la invitación a participar en este evento sobre salud cerebral y mental. Y gracias al equipo de Brain Lab por la acogida que me han dado en esta ocasión. Estoy muy contento de ver todo el trabajo que se va avanzando. Como Agustín planteó al principio, yo he trabajado muchos años en el desarrollo de métodos cognitivos para la detección temprana de las demencias, pero en los últimos años me ha llamado mucho la atención el desarrollo de nuevas tecnologías, especialmente con la motivación de cómo podemos incorporar los conocimientos que hemos desarrollado desde las neurociencias cognitivas en estas nuevas tecnologías que carecen de ese conocimiento. Como Agustín planteaba al principio, esta división entre cerebro y mente es vieja, es algo que nosotros venimos luchando hace muchos años y que todavía increíblemente a esta altura no se ha resuelto, a pesar de la evidencia contundente como Constanza nos mostraba en su diapositiva, en este resultado de este estudio de comisión de Lancet, que demuestra que la pobre salud mental en la adultez mayor está asociada al riesgo de perder la salud cerebral. Y este estudio demuestra que, por ejemplo, solamente la depresión, por sí sola, previniendo la depresión en el adulto mayor, podemos evitar el 4% de todos los casos de demencia. Fíjense, 4%, pero cuando uno mira las cifras, que al 2020 había 50 millones de sujetos con demencia y al 25 va a haber 152 millones, estamos hablando de millones de casos de demencia que se pueden prevenir simplemente por temas de salud mental. Esto es de la salud mental a la cerebral, y de la salud cerebral a la mental. No es secreto para nadie que todos estos problemas se presentan, estas enfermedades neurodegenerativas, muchas veces empiezan con manifestaciones de pérdida de la salud mental, y el diagnóstico etiológico y diferencial es una pesadilla para los clínicos, porque no sabemos, incluso algunos de los trabajos de Georg apuntan a la superposición de estos fenómenos a nivel biológico, y hablaremos de eso más rato en el debate. Ahora, ¿qué aportan las tecnologías? Las tecnologías están transformando la realidad en la que nosotros vemos, entendemos y abordamos estos problemas. La informática, por ejemplo, muestra eso, cómo podemos tener una visión mucho más holística de estos problemas a través de tener una cantidad de datos que nuestras mentes no pueden imaginar, pero las tecnologías pueden procesar. Estamos entrando en la época de la salud digital, que es fundamental, y a través del ranking de datos y todo esto estamos pudiendo tener una caracterización única, transversal y longitudinal de estos casos. Sin embargo, como hay buenas noticias, hay noticias que son aterradoras también. Por ejemplo, no se sabe si este artículo que salió hace nada más una semana, que demuestra que las tecnologías no están este estudio, que me parece increíble, donde se van a preguntar, se tomaron pacientes y haciendo preguntas sobre salud, sin ellos saber a quién se la estaban haciendo, a médicos y a chatbots, dígase a computadores. Se hace cuenta que el 78% de los casos estuvieron más contentos con la respuesta del chatbot que de los médicos, diciendo que nos tenemos que apretar sin tener seguridad porque va a haber turbulencias. Entonces, pues bueno, es parte de los retos que representan las tecnologías que enfrentamos. Por ejemplo, uno de los grandes retos, y precisamente motivación para mi trabajo, es que las tecnologías se desarrollan rápidamente, pero los conocimientos que ellas requieren para de verdad ofrecer soluciones duraderas, reales y basadas en el individuo de la persona, no la tienen. Hay un divide entre conocimiento y desarrollo tecnológico. Esto explica, por ejemplo, por qué las tecnologías no son significativas para el individuo. La compran, la tienen, a los 2 días la lanzan y viene otra y otra, porque no hay una herencia, no hay un elemento de identidad entre lo que la tecnología hace y lo que el individuo necesita. Y esto lleva, por ejemplo, las plataformas rígidas, los sujetos tienen que adherirse a lo que la tecnología puede ser, más bien lo que la tecnología capturar las necesidades continuas y cambiantes de estos pacientes, que es lo que llamamos la base de la medición de la medicina de precisión y la intervención personalizada.
Y importante en el campo de las demencias, por ejemplo, que es una de las áreas donde estamos trabajando, es que no son adaptativas. Un paciente con demencia cambia en la base del día a día, no digo a lo largo del mes, día a día, o ups and down, como decimos, la tecnología no captura. Eso es one size fits all y eso no funciona. Sin mencionar los aspectos éticos que brevemente nos toca al final de la presentación. Yo voy a compartirles rapidito dos trabajos, dos áreas de trabajo que hemos venido avanzando que se enfoca en implementar estas intervenciones y teorías de la cognición en desarrollo tecnológico. Una, voy a hablar sobre la salud mental enfocada en terapias asistidas por animales y en la salud cerebral en el uso de la realidad virtual, como un método para evaluar y además intervenir la cognición en función de la vida diaria. O sea, el uso de animales con fines terapéuticos es tan viejo como prácticamente el ser humano. Desde la antigua se sabe cómo se usaban caballos, etcétera, con efectos terapéuticos increíbles. A mí me ha llamado mucho la atención y en la charla te puedo contar la historia de esta motivación, pero hace unos años se nos acercó un grupo de Escocia, que es un grupo de caridad que se llama Therapeutics, o sea, mascotas terapéuticas. Y ellos tienen, sobre todo es un grupo de obra de caridad, y ellos estaban impresionados de ver los beneficios subjetivos que los usuarios que usan este servicio gratis experimentaban y preguntaron si se podía medir eso de una manera que se pudiera demostrar objetivamente que esa experiencia subjetiva tenía un correlato psicológico, fisiológico, y lo que hicimos fue que creamos un protocolo muy sencillo en el cual tuvimos una serie de medidas pre-post. Las medidas pre-post incluían medidas psicológicas y fisiológicas y dos condiciones, una en la cual se establecía una sesión terapéutica con el sujeto, el dueño de la mascota y la mascota, 20 minutos en una interacción, y una sección control que fue básicamente hacer un vídeo de una sesión terapéutica, y en lugar de presentarle al individuo al animal en su interacción, se le ponía el vídeo para observarlo, bajo el presunto de que es la interacción física con el animal lo que induce el beneficio. Más adelante le compartiré la sorpresa. Y medidas psicofisiológicas que medimos, como por ejemplo la actividad eléctrica cerebral, medimos la respuesta cardiovascular y galvánica de la piel y otras medidas para evaluar estos correlatos fisiológicos. Rápidamente, ¿qué encontramos? Lo evaluamos en el contexto universitario, en la universidad, estudiantes y trabajadores, que sabemos el estrés, que todos estamos, los actores de la educación superior, estamos involucrados, y lo evaluamos, y básicamente, ¿qué vimos? Que el efecto fue increíble. A nivel psicológico vimos que tanto estudiantes como trabajadores, miembros del staff, me reportaron un beneficio psicológico, 20 minutos sentado en el prado con un perrito, y la reducción del estrés fue increíble. Pero cardiovascularmente hubo una reducción en la actividad cardíaca que fue independiente de si vieron el vídeo o si interactuaron con el perrito, y a nivel cardiovascular, a nivel cerebral, que miramos un índice alfa-beta que habla de estado de arousal, relajación, vimos que el beneficio fue increíble, de manera que los sujetos, el estado de relajación y de reducción de estrés se correlacionó con la actividad cerebral. Eso fue interesantísimo, pero algo que vimos aquí en este estudio fue que no hace falta tener el perrito ahí contigo, que nada más ver un vídeo es casi suficiente para reducir el estrés, de manera que al otro año arrancamos de nuevo y dijimos, vamos a evaluar ahora, pero video-based Animal Assisted Intervention, para ver si es verdad que se pueden reproducir esos resultados, y un diseño muy parecido, pero en este caso no tuvimos que traer perritos, sino que creamos un vídeo, ya lo teníamos, de hecho, fue el vídeo control del estudio anterior, y lo comparamos con un vídeo de una escena natural que se sabe también produce relajación, y los resultados fueron prácticamente idénticos. O sea, en esta vez lo miramos en jóvenes y adultos mayores, y vimos que se replican los resultados. O sea, los resultados anteriores son exactamente iguales. Después vino COVID, y todo el mundo sabe el estrés que la población mundial se sometió a COVID, de manera que dijimos, una oportunidad perfecta para evaluar hasta qué punto estas intervenciones pueden ser útiles para el individuo en su casa. Y eso fue lo que hicimos. Desarrollamos un método de intervención remota, de manera que conectábamos con los sujetos y le hacíamos la misma intervención, exactamente igual, y los resultados fueron, sin cualquier cosa, más interesantes que en los anteriores, demostrando que, para resumir, son tecnologías. O sea, la razón por la que seleccioné este tema es porque son soluciones de tan bajo costo, de fácil uso, que se pueden implementar remotamente, que son muy atractivas para nuestros contextos latinoamericanos, donde no tenemos tanta plata para ayudar a las personas. Y hoy aquí ya se ha mostrado, como Constanza nos mostró, son soluciones muy asequibles que se pueden implementar con prácticamente mínimo personal y entrenamiento. Ahora, en la segunda parte, que es la parte de realidad virtual, hemos estado tratando de investigar, como decía, cómo podemos vincular teorías de la cognición y el desarrollo de tecnologías. En este estudio que hicimos hace unos años, nos dieron la oportunidad de ir al Museo de Escocia y reproducir virtualmente una sala de exhibición, de manera que podíamos ver cuando los sujetos hacían una tarea que era visitar una serie de exhibiciones dentro de una sala y evaluar qué capacidad tenían de mantener el orden, obtener información que había que recoger, y eso lo comparamos entre los entornos real y el entorno virtual, en jóvenes y adultos mayores. ¿Y qué vimos? Vimos que los jóvenes y los adultos mayores lograron desempeños muy similares, no hubo prácticamente diferencias, pero para que los adultos mayores lograran ese desempeño, necesitaron diferentes recursos cognitivos. Y eso es lo que queríamos saber, o sea, cómo podemos lograr que el adulto mayor logre altos valores de desempeño, ojalá iguales que los jóvenes, y qué hace falta para eso cognitivamente. Pudimos ver esto y también pudimos ver que esas habilidades correlacionan con escalas de funciones de la vida diaria que usamos en entornos clínicos, de manera que este estudio nos demostró que la realidad virtual ofrece un escenario buenísimo para explorar la cognición en the wild, como Agustín nos habla, en función de la vida diaria y correlacionarla como la actividad del individuo en su casa. Ya después dijimos, bueno, esto fue en el museo, era una locura, el Festival de Ciencias de Edimburgo, todo el mundo caminando, la gente, o sea, no pudimos cerrar el museo obviamente para hacer nuestro estudio, dijimos, vamos a hacerlo ahora bajo condiciones más controladas. Mi equipo de trabajo, nos inventamos con material reciclable, esta cocinita que se ve aquí, esos cajones son de cajones de televisor, y eso nos fuimos a los supermercados a buscar cosas, y creamos esta cocinita con un poco de creatividad, y un ingeniero en computación las hizo virtual, con las mismas capacidades interactivas, lo mismo que podía hacer un sujeto en la cocina real, lo podía hacer en la cocina virtual, y aquí pudimos desarrollar un protocolo mucho más preciso que nos dejó evaluar, por ejemplo, cómo le va al adulto mayor y al joven en entornos reales y en entornos virtuales, y pudimos ver que sí hay un efecto de la edad. La edad tiene un costo, cuando tú puedes controlar mejor, y ese costo no es siempre el mismo, depende, por ejemplo, de cómo tú le pides al sujeto que realice la tarea. Pero lo más importante de este estudio, que podemos conversar luego, es que nos dio lo que llamamos un marco cognitivo para la evaluación del desempeño en las actividades de la vida diaria en entornos virtuales. Es una palabrota larga, una frase larga, pero ¿qué quiere decir? Básicamente, la mayoría de las escalas funcionales que usamos hoy para evaluar vida diaria, función de la vida diaria, no correlacionan con la cognición. O sea, una cosa es por allá y otra es por acá, porque carecen de las teorías de la cognición. Aquí lo que hicimos es tratar de evaluar la función, la funcionalidad del individuo en entorno virtual y real, usando las métricas cognitivas que usamos en la evaluación básica, como la capacidad de memoria, el número de errores, función ejecutiva, inhibición, semántica, episódica. O sea que tenemos una interpretación cognitiva de la habilidad funcional, y como ustedes ven, las escalas claramente demuestran. Podemos hablar más de qué vimos en otros estudios. Bueno, tan atractivo ha sido este trabajo que colegas del Robotarium, que es uno de los centros más desarrollados que tenemos en Escocia para el trabajo en medios inteligentes asistivos, decidieron incorporar este marco de trabajo, y ahora, en lugar de ser nuestros psicólogos los que administran la prueba, lo hace Pepper. Miren. Ahora el sujeto empieza a hacer la tarea según el orden que se le dio. ¿Qué diferencia hay entre esto y lo que decíamos? El robot está conectado al entorno, son smart environment. Pues miren cómo alumbró un bombillo rojo porque el sujeto abrió la gaveta equivocada, no era la que era. El robot puede controlar el entorno, ofrecer claves, pero de una manera orientada por la cognición. Hacer resúmenes, o sea, le puedo mostrar el video más largo luego para que lo vean, porque ya estamos casi llegando al final, pero el final es desafiante, porque hay muchos aspectos éticos en el cuento que estamos haciendo aquí hoy. Y es que no voy a hablar de los temas de confidencialidad, protección a la individualidad, etcétera, que todavía estamos en el limbo en ese campo. Voy a hablar de temas mucho más sensibles que están emergiendo ahora, como, por ejemplo, estamos viendo que el desarrollo, apego, empatía que un individuo puede desarrollar con la tecnología es increíble. No solo como nos lo muestra el cine, muy elocuentemente a través de estas películas que podemos hablar también luego, que claramente demuestran ese elemento empático y afectivo que podemos desarrollar a nivel ético, donde se cuestiona si realmente esto es una forma de decepción. O sea, deception en el individuo, de manera que tú estás entregándole un robot con el cual él se va a comprometer a entregar, etcétera, y estamos engañándolo. La respuesta no la tenemos. De hecho, enviamos este trabajo hace poco, este evento sobre Trustworthy Autonomous System, donde preguntamos si es Trust Deception o Suspension of Disbelief. O sea, ¿dónde es que estamos en este campus? No es, el camino es largo, pero bueno, tenemos que enfrentarlo juntos. A manera de conclusiones, sí vemos que las nuevas tecnologías sí están creando oportunidades que no existían para aumentar el acceso a la atención médica y eliminar barreras asistenciales y geográficas. Sin embargo, todavía vemos que hay muchos desafíos en relación a considerar las preferencias y las características de los individuos que la van a usar. Se necesitan esfuerzos interdisciplinarios, eso ha quedado claro. Estas tecnologías, para de verdad ser útiles, para de verdad cumplir con su objetivo, tienen que traer conocimiento de nuestras disciplinas, de las ciencias de computación, e incorporarlos de manera que podamos desarrollar productos que el individuo se vea reflejado en él. O sea, no vamos, esta parte empática la tenemos que seguir analizando, pero tenemos que hacer más cercana a esta relación. Todavía hay barreras para garantizar que esto suceda, y lo que estamos viendo, por ejemplo, con la pandemia, que con la pandemia pudimos hacer un cambio increíble. O sea, no solamente las que ya venían, sino reusar tecnologías existentes para dar acceso a individuos que estaban en su casa, que perdieron acceso a los servicios médicos, que perdieron acceso a cualquier forma de intervención. Y aprendimos que con tecnologías baratas, sin tanto costo, podemos transformar la vida de esos individuos y garantizar el acceso y su salud cerebral y mental. Entonces, muchas gracias por su atención.
Wonderful, wonderful presentation. So now we have been going very fast through an amazing number of topics from spatiotemporal dynamics in depression, and I hope we can discuss in neurology, because we are working together, George, on that, so don't forget that. And then we have a wonderful presentation about allostasis and how we can use this battery of allostasis across multiple disorders. Then we have a wonderful talk about mindfulness and how mindfulness can impact different aspects from mental health to different mechanisms of, brain health that we are really looking forward to. And Mario make a great presentation about digital cognition and this challenge that we have ahead. So now we have a coffee. You can grab a coffee there, 5 minutes, something, and come back here and bring all your ideas to discuss. We will do it in English, just for having yours on board in the discussion, but if you don't speak English, you can make it in Spanish and we will translate for you. Okay, thank you. Gracias. El mate de micrófono.
No, claro. Tenemos para es ahí para subir o subir ahí más rápido. Sí, no, sale carito, pero
Ahí.
Pero le ponís como el de la otra tenés que marcar en el mapa. Y después del botánico te lleva al botánico, porque querés que te lleve acá. Un poco más de la área de la condición. La de no, esa me la tengo que era la que más me decía sobre tanto de dinero. Claro, en resumen, fue la temporalidad del funcionamiento cerebral y el funcionamiento del cuerpo paralelo de manera unificada. Pero la idea es medir diferentes dimensiones corporales, cerebrales, psicológicas, tecnológicas, experiencias, todas a la vez y de la manera más unificada posible, pero hasta a nivel solamente relacional, la cosa de medir todas unificadamente y tenga sentido en todo eso, creo que está poniendo y que las escalas en el tiempo, se miden varias cosas en el tiempo y con la comunicidad de los diferentes fenómenos por ahí relacionarlos mucho más directamente. Sí, lo que estamos conversando con él. Bueno, dale, estamos también, pero Max. Hola, ¿cómo estás? ¿Y tú? Oye, ¿qué te parece la universitaria? La de Dios totalmente fenomenal. Sí, oye, pero como no con entrevistas, sino con experimentos, con la titulada, experiencias subjetivas. ¿Y habló con la titulada? Sí, nosotros le hablamos de y de todo eso, pero no, bien, para totalmente sí, estaba súper. Yo lo que me fue el experimento de tesis y podéis ver varias escalas y la de profundidad de la correlación. Si tú tenías ideas de edad, de corazón, de cerebro, fenomenológica, claro, y tengo una dinámica, tengo estructura, ahora estamos haciendo el análisis de datos y hay dinámica temporal que son diferentes. En las entrevistas fenomenológicas, hay entrevistas hay sujetos que mantienen la angustia, otros que disminuyen la angustia. Esas son como las dos dinámicas temporales más claras. Un baseline mínimo se va manteniendo o bajando. Uno tiene un texto, se mantiene en una estructura de unos 600 y otro quizá ahí donde voy a ver qué pasa con todo el sí, hoy contarse hoy día montar que no le digo tuve una experiencia buena, sí, pero activa. Dijo que había visto a una lucha, me dijo que yo como es que acá con una sesión, y después salió, y nos quedaron que de repente no maestro, no, claro, no se pasó. Yo no les he dicho, porque no sé qué se pasa en la voz. Sí, pues siempre pasa un poquito y les voy a decir que no le digan a nadie, pero no tengo confianza. No tengo confianza en cómo controlar esa relación estudiante, compañeros, de experiencia y estilo. Yo trabajo igual con la entrevista, pero no todo el tiempo estoy a comparar, no me puedo estudiantes también nos quedan conversando, porque van a ser una usa. Lo he visto en todo. Pero claro, porque van depresión. Igual hay que tener. Sí, pero a ver, con que te crean, yo creo que eso está buenísimo. No, que al final está ahí evocando lo que quieren. Claro. Pero sí, bueno, sí que ella no tiene, creo que su papá o abuelo que le marca, sí que le receta. Sí, interesante. Hoy está intentando solamente tocar un tema en el intro. Sí, por ahora, sí, no he tenido tiempo para analizar lo otro, pero están buenas las entrevistas. Yo la parte que puede tener término de la empatía, porque son como dos fenómenos tan percibidos y tan líquidos, que no están graduados, como hay una muy corporalmente, otros que tienen otra relación, otros que tienen otra realidad, otros que tienen perspectiva en sí mismos, como que tienen como si fuesen ellos, otros que ellos son totalmente centrados en el otro. Yo creo que tienen cambios, la perspectiva de ser pasada. A veces en un momento son ellos, otra vez son el otro. ¿Y qué es lo que cambia eso en el momento de la entrevista más cargada negativa? Sí, en eso me estoy enfocando. Entonces, en el último, cuando digan, ahí todos son como se centran en el otro. Hay objetos que tienen esa situación de la perspectiva de su paciente y hay otros que se enfocan en esa línea, como piensan que se desconectan de hay otros que se conectan también y ahora tengo que enviar en Facebook. Ahora la tengo que submitir en Facebook teórico, una revisión. Bueno, lo cambiamos de ¿qué va a pasar? ¿Qué va a pasar? No sé, están los puntos 3, 4, 4, 4, 4. De 5, de 5. Aparte de por último, te va a pedir la revisión y tenemos que sentarlo. Sí, ahí por ser soy optimista. El otro no juntó un poquito más bajo, pero igual que 2, 3, 3, 3, 3, 3. Estamos como ahí, arriba de la media. Arriba de la media y la modificación es como. Tiramos todo. Antes éramos antes éramos como cuando estaba en la primera vuelta. Ahora estamos criticaron y ahora estamos como en el medio. Cambio de discurso. La programa de progresión integral, metodología de laboratorio, con lo económico. Y ahora van a ver, vaya a ver si la aceptan o no entrar como. Claro. Claro. Bueno, ya lleva el mal. Oye, yo solo las emociones negativas iban muy diferenciadas. Lo interesante es que el reconocimiento de emociones positivas y la metacognición de emociones positivas que dicen la relación social, esas no es negativa, están ahí interesantes. En el contexto de la aplicación, lo que intuyo yo es que por algún motivo las emociones positivas son resilientes, de reconocimiento de emociones positivas resilientes, y en base a eso, es que las personas intentan compartir la posición de reconocer si las emociones son positivas con la posición. Por eso es que es relacionar con la posición. Pero el reconocimiento de emociones negativas no es casi todas las negativas que se tienen en y que por algún motivo no aporta no se reconoce la persona. Pero es muy interesante porque igual hay que haber tratado al posicionar el proceso emocional y el socioeconómico y resultados súper variados. Primero, que por qué da el tiempo segundo, que se relaciona con la sociedad y Una que vendría siendo como la que dice que los filósofos nacionales para hacer una perspectiva y que dicen que para poner el otro, etcétera, puedan proceder una cascada de los objetivos hacia los emocionales y comunicación económica impacta los procesos cognitivos que es los procesos emocionales, una cascada, y la otra dice que la emoción y el funcionamiento emocional generar lazos cognitivos y comunidad. Y eso, esta línea te muestra que es un tipo de más empatía, más empática y para claro, salió lo contrario a esto, que emociones negativas. Sí, claro. O sea, reconocimiento humano tiene menos, pero está totalmente contrariado con la negativa. Algo pasa con los investigadores, seguro. Y algo no está pasando con la investigación. Puede ser amenazante porque de hecho, esta teoría que dice que es adaptativa, es adaptativa vital para la sobrevivencia, pero es que ya es prácticamente lugar para el segundo partida
So I just will do a brief introduction. So if you can see across the different presentations, we are talking about a very old-fashioned distinction. What is physical world, what is mind, or what is, you know, causal explanations versus other explanations. And this reminds me specifically in the field of mental health, this kind of escission, you know, this scheme between both fields, it have tremendous effects. You know, in La Tourette syndrome, it was a condition that was jumping from psychiatric to neurological disorders. So it was a genetic conditions versus was a repressed masturbation by Ferenczi, psychoanalytic theory. They come back again and was confused with Huntington disease, that is another disease. And this is just because we don't have good models to understand the similarities. The same way that Georg is, you know, connecting brain and mind, we can do in psychiatric and neurological conditions or in mental health in general. We know a lot about from influences, exposome, external influence, lifestyle choices, to internal mechanistic pathways, inflammatory, endocrine, immune, microbiome, etc. But also we know that we have tools, theoretical tools that can integrate, can be dimensionally applied between the both sides, and also interventions that can be applied between both sides. So it's a great start. I have a question for George when he's ready. And so I just want you to bring your voices. It's a huge opportunity for make questions for the speaker, but also for provide your own insights. So I will open the discussion right now. If there are no questions, I will start with George. Can you talk a little bit how your approach can be extended to neurology? I mean, we have been working together. I'm pretty sure you have some own ideas just to bring this discussion about, you know, psychiatric and neurological conditions.
Okay. Yeah, first and foremost, of course, you have depression and anxiety in your patients too. Frontotemporal dementia, Alzheimer's dementia, minimal cognitive impairment, probably maybe even in the subjective cognitive impairment, which would be an interesting candidate. So definitely I would screen the literature for that, and that of course should be, it's a syndrome. So that would be, I think, the most direct link, and probably many of these symptoms lead you to the doctors, maybe even before the memory complaint. And the second thing, of course, then I would need to go into some of the memory complaints they have. And for me, it would be very interesting, the earlier subjective impairment and minimal cognitive impairment. And then I would look for those memories in dynamic terms. So what does this mean? I would, for instance, we have a study now where we analyze working memory in dynamic terms. And I would do the same here. And maybe particularly in these early stages, I could imagine the memory function itself is intact, but you have some dynamic changes. And I know that the group by McIntosh, former Toronto, now in Vancouver, they did some of this variability and dynamic stuff in early ages, and you see changes. Yeah, you slow down, maybe that I could imagine. So I would look for that, and then you can apply the same kind of measures, or some of those measures which I have, particularly with the cognitive memory paradigm.
I just want to mention that Mario has been developed this binding working memory task versus future integration, that the binding requires integration of future, I mean, color and the form of the stimuli. We have a lot of data, including EEG and fMRI, so we can apply your spatiotemporal. Yeah. So the direct hypothesis, we will have longer time window for binding in comparison to future. And
I would.
And we have all the, it's a classical working memory task with, you know, study and set. So we have this long period to calculate the ACW, and yeah.
So show me the exact temporal structure of the paradigm. I look at the temporal structure of the paradigm, because cognitive people neglect that. That's an intertrial interval, interstimulus intervals. I'm very keen on this. And then I can tell you how to analyze and what I would expect.
Fantastic, great. Any question, please, Jose?
Thank you.
Thank you, George. So, really nice talk. I was wondering whether you have thought, or other people have thought about integrating body signals into this general flow framework, either in the processing of signals or integrating those signals.
Yeah, good question. You're absolutely right. So, of course, I would argue in our sixth paper last year, we postulate that, and that the ACW autocorrelation window is strongly involved in input encoding. So here really focus on the encoding, not the decoding, which is an important difference. And then need to tell you that one. And of course, the encoding is not only the external input, it's also the continuous internal input. Internal input from the body and internal input probably from strong variability changes within the brain itself, because they might be treated like an input, like spindles. In the case of sleep, in 1 and 2 sleep, it's like a strong internally generated input, thalamus cortical variability change. And of course, I would argue that they processed by the and encoded by the same temporal mechanism as external inputs. So meaning, I know I made a little detour. Of course, I would argue, and we already discussed this in one study, link from particularly the autocorrelation window to the heartbeat evoked potential. And I know that there is one study, for instance, for scale-free activity, BUH, it's a power law exponent. And of course, you see responsitivity to the heartbeat. So it's clear because it's a scale-free system. Yeah, and of course, the brain will react. And that's for me. So if you want to put it in a larger perspective, it's complexity matching. Bruce West.
A comment on that and connecting with allostatic overload. Now, after hearing you several times, but after this visit, I understand the relevance of encoding in your approach, right? So the inputs, this is so, because it's not the typical way that the people interpret inputs. And when we think in allostasis, you know, it's supposedly the responses to environmental demands, but those responses depend on your internal organisms, your dynamics, your internal dynamics, your encoding of this external information. So I see better links that our paper already submitted to connect allostasis with these internal time scales, like, you know, the internal structure, not only to respond to environmental demand, but to explain the heterogeneity, you know, because same stressors can trigger different internal states, or even exposome. You know, you can understand the exposome like external trigger, but you have a lot of internal signals, you know, that exacerbate the exposome. So if you want to, I mean, imagine you have a lot of money and you can measure wherever you want. What should you choose for an allostatic index? Sorry. Use the.
Right? Yes. It's a difficult question. It's exactly the same question, the use of biomarkers in Alzheimer. I mean, if I have a lot of money, a lot of funding, I'm going to use several. I mean, most of them, the primary ones, I mean, all of them, because all of them are related that we can find this type of allostatic index.
Wait, because maybe I was saying too much. Imagine that you don't have all the money, so you have to pick up 3 of them. What should be the best?
Yes.
Yeah, exactly.
Yeah, I know how to, what can I use? The first one is cortisol, of course. The second one, something, how to say, cheaper. This is how to say, weight, yeah. And the third one is the immune-inflammatory protein, directed protein.
Thank you so much. Other questions? Please, first Mario and then Caroline.
Okay, so I got a question for you about the interesting, fascinating series of historian. Really important. Thank you for sharing them. I have when it was.
Wait, you need to go for now, please, because we had guests online. Yeah.
Okay. When you started your presentation and you talk about this speech brain modulation in people with depression, I thought, well, this might probably be changed somehow, but then you showed that you have used TMS to kind of restore or try to. So then, and I was wondering if you have thought or whether it would be feasible to use biofeedback, some form of biofeedback in this patient with depression to kind of speed up.
Like entrainment, maybe, or what are you thinking about?
Well, I'm thinking EEG-based neuromodulation biofeedback, because you show that frequency changes as a byproduct of depression, and that's why they tend to process things slowly and so on and so forth. So then if we feed this information back biologically, and there are many ways to do that now, could it be possible to kind of help them, bring them back to track in terms of speech at the neural level, and therefore hopefully at the clinical behavioral level as well?
Yeah, I mean, that's exactly the idea. So that's what I would do if I would individualize. So we individualize the region. Now I'm really looking forward to a large clinical study, and there I need what you just promised, a lot of money or facilities. And I cannot do this academically. That you really have say, okay, you have a 3-arm study. You have either motor cortex, visual cortex, or dorsolateral prefrontal cortex, according to the neuronal and psychological deficit. So you have a working memory task, probing the dorsolateral. You have a motor cortex task, which I didn't show you, a motor tapping precision error, which we can do. This is established, and we have the psychological visual task, as I showed. And then the next thing, you want to do EEG and fMRI and measure the dynamics and do a power spectrum of those respective regions. And compare that also with the behavioral data. So you do a power spectrum of the behavioral data too, for instance, of the finger tapping, how much they're lagging behind. And then you have basically the power spectrum on the behavior level, as well as on the EEG and on the fMRI, the infraslow range. And then you get sort of an overview of different time scales and see how they relate with each other. You can do mutual information. You can do a vector autoregressive model for linking these different time series. And then you see how they are linked to each other. So that gives you sort of a fingerprint of the neurodynamical basis of their behavior. And I'm insisting here on the behavior, because so much in therapy goes either pure on the psychology or pure on the neuronal, and that's Nick. And I would like to even include my subjective experience scales. I'm after all a phenomenologist as a philosopher, where I'm coming. So also this depression, which I didn't show here, the time-space experience scale of depression. So if I have that, and then I have the data to go into a computational model. So then ideally, you clever guys, you converge my EEG data, my individual EEG, with the computation. I remember the 2 red points, dots we were discussing. So then you can simulate how I can change that particular neuronal dynamics, PSD or whatever, or autocorrelation window scale. And of course, you probably also want to have a dynamic autocorrelation window, which I didn't show here, which you need to have. And then how I can change and how I need to tune the computational system to change that frequency. And that will be, again, for each subject differently, which I suppose depends also on the dynamic repertoire / the variability range. That's why I want a dynamic ACW.
Absolutely. And I think that's bringing the biofeedback to a whole new level.
And then he can give me the exact data. And then I come to you, and I don't know, you seem to be a social scientist, but maybe you can build me the right machine where I can implement that with a continuous online feedback system. So I start with the frequency which he recommends me, the red dot, how we can shift it. And then we can build this. But I would not do this before, because now the current data on BCI and TMS are at best.
We need to capture the individual temporal dynamics.
That's a framework towards personalization.
That's really
exactly that.
Because personalization and precision based.
Exactly. Yes. That's it, because you really have the holistic approach to the individual, not just the biological, the psychological, or the environmental.
So what I can do, this could be run in a larger clinical studies, either the TMS, with the 3-arm TMS, and with the computational model, or for the breathing. The breathing might be a slightly easier thing. The only thing in the model then is how do you apply a breathing pulse to the model? That's not an easy one. Because the input is the real problem of the formalization of the input on your side. We discuss this in our group. We have no solution to that. Because you just usually do, So that's sort of...
No, I think that we need to make a discussion between breathe and mindfulness, but first, Caro, have a question.
Thank you. So can you hear me? No? Yeah?
No.
Okay. Yeah,
Perfect.
he says here.
He's a guy.
So I have 2 questions for 2 speakers. So I will start with Georg. So you started your discussion, your presentation, saying that models addressing genetics and disease are not enough. So you said in your presentation that models using genetics and disease, those kind of models are not enough. I'm wondering if we are missing some part. So since I have a background in epigenetics, I'm wondering, well, these epigenetic changes have risen as a mechanism connecting genetics of a person and experiences, environmental stimuli. So I'm wondering whether you think that maybe genetic regulation through epigenetics can add something to the topic.
So first, I ask clarity. My argument was not against genetics, it was against the case number.
Okay.
The case numbers are not sufficient. And I used falsely now genetics as an example. Okay, anyway, so first and foremost, I'm not an expert in genetic epigenetics, so I cannot say much. So this is so everything I say, it just comes from a very bird's eye view from somebody who has no expertise in that. But just say, coming from my clinical side, now I speak as a psychiatrist, what is clear, life events play a key role in that, in different ways. First, they trigger the event. Basically, all depressive patients, they have, and it's not the objective life event, it's the subjectively perception of that life. Two, Claudia and I, two different people, same life event, exactly the same life event, I become depressed, she remains normal. Okay, so don't tell me why that is. So, and that's a problem, because that depends, and that's why I would argue, remember this one slide where I had the childhood trauma and the time perception. That's the thing, yeah? So, and that I think, and then that's a triggering life. But then you have also more constitutive life. Trauma, continuous trauma. You become depressed or you react with a PTSD or post-traumatic stress disorder, whatever. And of course, epigenetic changes are absolutely clear. That's what, so far I can go. I cannot go further because I'm lacking the expertise.
I can complement a little bit on that. Oh, sorry. So first of all, I think that we have a bias with genetics. We tend to immediately forget that the genes need expression and genes are inside an organism. You know, this is so important. And when you start to thinking about a more complex genetics, right, like CMBs or PRS, polygenic risk score, right? The interaction with environment is critical. And when we talk about epigenetics, oh my God, you should be interested in that, because one important thing is epigenetic clocks. Is dynamics, is again, temporal dynamics, and how the burden across all the lifespan modulate these clocks, interacting with the genetical predisposition. So I think that we need more of this kind of dialogue, you know, because as in Red Lab, we do a lot of genetics, and it's incredible the huge opportunities we miss to connect the dots from environmental factors to genetics, and then to this important aspect of subjective experience, right? So
Totally agree.
we need to change that dialogue.
If you can provide timescales with enough data points, yeah, I mean, I'm talking at least 100 data points, if not more, then we can do the same measures. Like autocorrelation window, one of my favorite, as you probably figured, but also other sample entropy, what we did in the schizophrenia.
Exactly.
That we could do, because after all, the different levels must communicate with each other. Of course, my assumption is that's temporal. So if the encoding process between brain environment is temporal, then it's a reasonable assumption that maybe the encoding process from the inner of the organism and the different layers is also temporal. Yeah, I make a very strong claim here.
Imagine a kind of...
But then meaning we could link. And ultimately that should be scale-free organization. So the same kind of pattern which you see in your dynamics of your epigenetics, I should somewhat see similar pattern in my smaller timescales of my brain timescales.
That would be great to connect.
Relationship.
Exactly.
Yeah, that's scale-free. So you provide a large Russian doll, I just said a small one, compared to your time series. Maybe, but I don't know.
But this can bring, you know, spatiotemporal dynamics beyond the brain, because you can create spatiotemporal metrics of different organs modulated by the epigenetic clocks.
But it's a temporal code.
Exactly.
Connect them. It's a temporal coding process. That's why I'm keen. Yeah. English is our common code now. It's the only one. I don't speak Spanish. Yeah. So there we are. Yeah, if you don't, that's like the temporal code in the brain for me with the brain-body environment. So the principal difference, I'm sure that the brain, you know, I always think that the brain sits here and listens to us and says, how stupid are you to separate me from the body and the environment? It's just one thing for me. Yeah, it's just a matter of balances, it's continual. And that's what the patient tells. Yeah.
Second question.
Yeah, I have another question for Constanza this time. So I was seeing your presentation with great interest, and you mentioned some different effects of mindfulness on different biomarkers, cardiometabolic biomarkers, stress biomarkers, etc.
Telomerons.
Yeah, telomere length, yes. So I'm wondering whether there's maybe some study you have read, or maybe you are familiar with, since you have a background in biochemistry. Have you seen any study reporting any gene expression changes related to mindfulness?
Okay, so I don't know if I think it's not there.
Él lo escucha por el audio, así que
Okay.
sabe cuando...
Okay, great, thanks. So the exactly mechanism how this happened, I mean, the most close we are is that we have some pattern of activity in the brain that, for instance, you encode for something that is kind of very real or not real, and there is an encoding there, and that information goes down through the eje hypothalamus-hypophysis axis, and you generate a you know, a solution of different hormones, and that's it. So that is kind of how the things happen, and then you have the cortisol that Claudia explained, to adrenal. How this happened with genes is not very clear. There are epigenetic modulations, but not, I mean, it's to the level of gene expression, but not gene like modification, of course.
Yeah.
And this is related to the measurements is more that have been targeted is in pro-cytokine inflammatory expression and interleukins also, and yeah, kind of this range of like pro-inflammatory environments in a way. And this is through methylations, and this is the mechanisms, methylations of, yes. But exactly how that is orchestrated is not really very clear, because also there is some confoundings in I must to say and disclaim, in meditation studies, especially with the advanced meditator studies, where are a lot of these findings that has to do with the lifestyles that you begin to have when you engage in meditative or contemplative practice, like the degree of awareness of your alimentation and like bodily awareness, making sport or not, that also generate like an holistic change through pro-inflammatory, I mean, decreasing this pro-inflammatory environment or stressful lifestyles that we could have. So there are some short-term studies with 8 weeks showing already epigenetic change, and also in telomerase is the minimum time for expression. But normally the biggest effect is for longer time, and then you begin to have a confounding with lifestyles in general. So yeah.
One more little thing. I'm curious for myself. Is there any like type of person that is more prone to meditate like easily, to be like advanced meditators? Is there any predisposition or some type of person that meditation comes easily for them?
Really, I'm not sure of, I mean, there are some studies about relating the big five with like, because you have like some like trait mindful outcomes, you know, you have like state mindful or trait. There are people that is normal, more mindful. Like if you pass to people in this room, the mindfulness scales, there are more people, even though they don't meditate, that they're going to have a more
like mindful traits. Yeah, but people that normally approach to meditate is people that is normally more anxious and have normally more prompt to be anxious or to be stressed. And people look for meditation when they are in not very good mental health shape, which is natural. It's like looking for medicine, but in a way of practice, in a way. So I would say that people that approach to meditate for mental health reason normally is a select group of anxious people. And but then this has its consequences, of course. And but there is people that is more disattached or that have less cognitive fusion, that is more like mindful as a trait in a continuum. But I don't know if for these people it's more easy to meditate, because always there is some, I mean, there are obstacles for each type of people, right? So there are people that it's going to have some fight with their like solidification of thoughts, and there are people that have a profile that is more evitative. So his evitative patterns of thinking are the obstacles for them when they come from their meditation. So it's variable.
Comment on that for you, Constance, and maybe for yours also. So as you may know, this question that Caro has made is very important, because probably you are very aware about this. I think it's Nature Communication or Nature Human Behavior paper showing that the effects of mindfulness are not such strong as we believe. And there are a lot of failure. But the question is personalized medicine. So what's the degree of mindfulness or breathing? Or, you know, if we are thinking about mechanisms for self-regulation, perhaps that is one of the mechanisms associated with mindfulness, or reducing allostasis, right? Why we don't think in multi-component interventions? In the field of brain health, the multi-component interventions are the best, no comparison with any other across all possible interventions. So maybe exercise, breathing, and mindfulness combined and personalized, right? So maybe you want to mention, Georg, how you personalize the assessment of breathing, so we can, but first let's start with your opinion about this.
Yes, sure. So we published a paper last year, actually, how mindfulness-based intervention were differently efficient for different types of mindfulness-based baseline people. So for sure, there is a thing of baselines where people arrive with, and also there is a timing that is very important. For instance, for the things that I show for depression, it's not when you have the person in the more acute episode of depression, but it's when they are really for relapsing. And so I think it's very important what you mentioned, because actually what you are fostering is a kind of a mental culture of not going to the doctor in a way when you are like completely done, and when okay, great, sure. And so you are fostering kind of a more preventive, a more holistic approach. So you can tune whatever you need to do, more exercise or have a better alimentation, or if you are like not sleeping too much because you need to do this, you need then you kind of counterbalance meditating or whatever. So yeah, hopefully we arrive to something like that. But to prevent like dementia or all these things, normally you have to try to sustain the better lifestyle you can do ever. So maybe it's useful to do some kind of, it will be very exigent, but to do kind of a lifestyle index, like that you could, okay, that you can kind of put there your credits on meditation and running and stuff, and to see like basically how much drinks you can have in the weekend without like, compensating your oxidative kind of, yeah.
Intervention doing all this from diet, sleep, breathing, not mindfulness, unfortunately, but it's a very nice study running across the world. I don't know if you want to comment on how to title these.
Yeah, interesting comments. I mean, first of all, I think one thing which is really neglected in the meditation literature is the induction method. And the data on the neuronal side are extremely heterogeneous. because you have all kinds of induction methods. I was in India last year invited, and I mean, you can't imagine what kind of breathing techniques they have through the nostrils, different nostrils, and it's insane. And of course, when you're there, you have to undergo all of that because it's only experience counts, not the knowledge. It's incredible. So anyway, so I think that's a key thing. So different people prefer different induction methods. That's of course, and I would argue the meditative state is a common final functional pathway. I know that some review of our papers killed that figure. We had a nice figure, different induction, they all lead to non-duality. And I would keep the induction techniques in a very wide sense. For me, for instance, I'm a runner. So I like run, and when I'm in nature, that's like a meditative state for me, a flow state. So I would define that very wide. So meaning that's where you need to individualize. And now we actually investigated, we have one paper in preparation, where we really look for the different kinds of induction techniques, how they, because that's input encoding, it's internal input which you encode, the breathing input or mental input, how that relates, of course, to my beloved measure of ACW. And one of the reasons why I'm so focused on this ACW is also a pragmatic reason. We have other measures, power law exponents, they don't yield, in those contexts, they don't yield those results. For other, yes, you will see this in our lab. So that's internal input encoding that leads back to the question which you raised for the heartbeat and the intrinsic neural time scales. Yeah, so also the internal input is encoded. So now I would then basically, let's say again, I would do a time scale profile. Maybe a power spectral, then of course I need to provide better neurophenomenal connections, but then I would go from there and individual, and that maybe that induction method is the right thing for you. Yeah, so that's the way I would individualize. And one thing, sorry to rain into your parade, there's a lot of aversive effects in meditation. So I'm, as a clinical psychiatrist who wants to apply meditation to psychiatric patients, needs to be very much aware of that. Yeah, and again, last thing, so that's again, it's very important, who gets those aversive effects. So meditation is not just good, can also be bad. Like everything, like the psilocybin can be very good, it can be a disaster.
Psilocybin in an next meeting.
When you have the wrong context. Yeah, so in last comment on that, so when you're in India, the people smile on the mindfulness because they say, that's not meditation, and meditation is not Buddhist. And you also said mindfulness, meditation, sort of, I think you used the terms interchangeably. It's mainly for, let's say, people with anxiety, depression. That's the Western world. Meditation has a very different context when you go to China or India. Completely different. Yeah, so very, very important. And what is presented as mindful, okay, now I do 5-minute mindfulness, and then I'm able, and then I'm more capacity and can have more success. That's not the context for mindfulness. So I'm really, I live over there, so I know how they do it. I'm strongly against it. It doesn't work. Yeah, and you can see this. It may work superficially.
Let's discuss. Let us know.
So that's context.
Okay, I will answer about the secondary,
About the challenging effect of meditation. They are recognized as any prescription or whatever, and has to do, as you say, with the person and who is prescribing the thing. So normally, panic attacks and difficult events that happen during meditation has to do with. It's very similar to exercise. I mean, you normally, if you decide to run a marathon, you are not from nothing going and go to run a marathon because probably you're going to have some problems with your muscles or your knees or whatever because you are not prepared. So normally you have to prepare it and go very, like, increase the frequency very slow and everything. And normally panic attacks and all this kind of secondary or what is called the dark night of the soul or meditation has to do with this doses that is people from the West that goes and from being really like running ahead with their jobs and everything, they sit and they have this panic attack when they sit for 2 weeks or something like that. And also when they are in a very bad depressive or anxiety state and they sit to meditate, then they have this thing. So
these secondary effects happen basically for a bad management and prescription of the technique, but it's not the technique itself. And regarding what you said about the how mindfulness is seen in the West, I say that actually that mindfulness was integrated in the West to make front to stress and lifestyles from the Westerners point of view, you know, like anxiety, depression as kind of a prescription. And in Oriental countries, it's a lifestyle to live like that. And that's why I'm saying that what we are trying to achieve is not this only mindfulness stuff, but that's why I'm advocating for something more holistic that has to do with lifestyles in general, where meditation is one component that helps you to be aware of your habits and helps you to change your habits because you become better to sense yourself and sense the rest of the people, basically. Yeah.
Thank you. Other question. So Rodrigo is not paying attention to the computer and is absolutely insightful about the discussion. So do you want to make any questions? Okay. So
you caught him in a meditative state. That's why he can't answer. I have a question for Claudia. It's about now that you have done a review and kind of characterized the status quo, let's say. So I guess you are getting ready kind of start using this approach. Then I'm wondering about Red Lab, whether, because Red Lab has been gathering a lot of data, and I get from the existing data it will be possible to draw some of this allostatic measure. So then, are you planning to do that? And if so, remind me, what did Red Lab eventually started before the COVID pandemic, or you had to start after?
We started before.
So meaning that you have before and after.
Yeah, but no, because for before we have only pre-existing data that was collected previously.
I was wondering because I just wondering in case.
Otherwise it will be great. Yes.
Yeah. Well, in any case, so then you have post-COVID data. At least you could look at because you have environmental, you have all the humoral.
So Claudia, probably.
Yeah, go ahead, Claudia.
¿Se escucha? ¿Sí? ¿Está bien? Thank you, Maria. Yes, we are planning to do a lot of things with the plasma samples. So first of all, we would like to evaluate the most important or more classic neurodegenerative biomarkers, say beta, tau, NFL, and of course FAP. But also we want to evaluate this type of allostatic biomarkers. Well, if we have money, of course, we are going to evaluate everything. But I think that now we have some preliminary data from the collaboration, because the collaboration with Andres Lachevsky. And we have this type of immunoinflammatory proteins, but yes, some of them are related to this allostatic low biomarker, but I mean, we can use it for the renew one and everything. And yes, here in this preliminary data, we have healthy controls, the MCI or the Euro cohort patient, and also AD. I don't know if we have some FTD patient, but probably. And now we are planning to do something with I'm sorry, Jen. We are planning to do something with the CARD funds and with an association with the NIH. And yes, we are going to have some preliminary data for the renewal of the R1 for the rep.
And I want to add two things of that. We are also starting to do exposome mediation, like social epigenomics effects in the methylation and many different epigenetic clocks that, by the way, many of those doesn't work in our population. You know, it's a very important and already reported Hispanic paradox is called. So the patients are younger than the controls, but some clocks related to aging are working well and showing the strong effect of the environmental factors, accentuating the chronological gap. Sorry, this is one. And the other thing is we want to do allostatic interoceptive network in all of our patients. We are going to do that. And with Georg, we just started to I would say, change the idea of predictive coding in a linear way, using his spatiotemporal approach, and I want to try it in the allostatic interoceptive network for the frontotemporal dementia patients, of course. Yeah, we are going to do it, yes.
That's great. I got another question for Constanza as well.
Sure.
By Mike. So that I think it's fantastic. Mindfulness is just one is a solution that is working. It does work. But I'm wondering if you have thought about this idea of what Claudia presented about allostatic loads and mindfulness, because it would be very interesting. I said one side fits all doesn't work here. But the key of mindfulness, it works for some people, it doesn't work for others. But can we go from the subjective experience of mindfulness to some objective metrics, like for example, allostatic load measure, that can allow you to identify who is objectively benefiting really from this and follow that on? Because that's not really a very expensive approach, is it? What do you think?
I think it would be ideal to be able to do something like that, but I'm not sure.
Yes.
So,
Yeah. Yeah, I think you can have, of course, you have an intra-subject variation that is like killing the biomarkers, like findings and everything. But you have people that is more successfully regulating and people that will take more time. And normally you do the studies and you say, okay, these people in 8 weeks, they didn't manage, or they manage, or they have different stressors from the outside. So basically what would you would like to do is to do an internal mark of one that people is managing the self-regulation and everything. And so you can use each one as their own start points and end points. And if some people need 8 weeks, good for them, because all programs and in the US, like mindfulness-based cognitive therapies cover for health insurance and stuff, but people need more time. And people who is under more allostatic load is going to need a more, maybe a steep or not so steep meditation apprentice and other people. So basically, to make it short, I think will be like some internal marker when people is basically regulating and he's in place with himself, and that could be subjective, but would be also nice to have like a more like biological marker, because people also lie to themselves. So
people can be called his or her own norms.
Yes.
So then you start from there, and then because it's so affordable and easy to do, then you can really measure it. You say, what is the objective measure to mindfulness, let's say, efficacy? You say some people take a week, some people take more than that. So, but are biological fibers of that? So, because you can draw from all static measures, reducing stress. I think that's interesting. It's bringing mindfulness to a new level in terms of going from the subjective to the more biologically driven approach to efficacy of this particular intervention.
Yeah, but the subjective part is also very important, because there is people that can be with a lot of cortisol and they are like, they are doing okay. And then they just burn out one day to the other. So
100%. I'm not questioning the subjective. In fact, that's the ultimate goal. The point is that the discrepancy in the community in terms of how we can really corroborate biologically, and if that happens, are everybody equally vulnerable to implement biological the influences of mindfulness? And if they are, can they carry forward this beneficial effect for longer? So that this knowledge is lacking. So I think that's very important to explore and a more biological, to bring the community together and solve these long-standing controversies in the field.
So sure, maybe to start to do some kind of clustering profile of, kind of people with subjective and like more lifestyle stuff and also meditation. So you can do kind of a prediction within a more like small like group.
Prediction, who's going to benefit?
Yeah, sure. Yeah.
Other questions? I think the computational core are very far away. There, Vicente.
Hi.
Yes, they can hear you.
First of all, thank you very much to the speakers. Great talks. I was going to pick up this last discussion. I think that I really agree with Mario that there's some like biological mechanisms lacking the relation between the environmental burden over neurodegenerative diseases and mental disorders. We can have, for example, the case of the depression. It's higher in higher socioeconomic status countries as compared to lower socioeconomic status countries, and the same for neurodegenerative diseases, right? The inverse, sorry, the inverse. So we have some like peripheral biomarkers that we can use to track these diseases. We have some like central mechanisms that are related to these diseases and these mental disorders, but there's a lack of the link between the periphery, the environment, the exposome, right, and the internal central mechanisms in the nervous system. So I think, for example, it's a good example to use the case of meditation, because it's a very like specific effect in metabolism. For example, we have an increase, a modulation of oxygen metabolism in the brain. Is it maybe related to, I don't know, like blood-brain barrier permeability, for example, that is facilitating the entrance of oxygen, for example? And maybe that could be related, I don't know, with ApoE gene that is related to cardiovascular risk and permeability as well. So all of those questions like have to be like unified in a common framework, I believe. This is just a general commentary, not a specific question, sorry.
Sure, I mean, that is the, you know, this cognitive, what was the concept I used? Cognitive, yes. I mean, this is basically, this is this intra-individual, you know, like cognitive protective factors, you know, it's like, it's the history of the system that is giving you also that variability, and is the one we can, basically we cannot explain. I mean, we want to make it the most predictable possible so we can take people on that track, but at the end, you don't know, we are still modeling this intra-individual difference that make people more resistant or not according to their lives in general.
And I think that your point is an overall question. So it's happened right now, and we lack theories, we lack evidence, you know, and it's not only to bring causal explanation, it's connecting the levels, because this is the main challenge, and it's an academic barrier. It's not I mean, in nature, this happened together, but we have been used to study, you know, in a very isolated way. I think that we are starting to do it. And I think that theory, I know that George is not a fan of the philosophers, but we need to bring theories that can integrate levels. Neuroscientists cannot do that at all. They are not prepared for that. On the contrary, they are prepared, you know, for the micro level and isolation, you know, internal control, isolation, that's it. But we need theories that really integrate the dots. We are just, you know, doing a small dots of that, but we don't have a common approach for that. Because of that, I like allostasis, by the way, but it's, yeah.
So don't misunderstand me. I'm not against philosophers. I'm against particular philosophers.
Yeah, I know.
So what is currently dominating in the un-American mind for the meditation. So that we develop what we are going back to that example. So we're going back, we indeed develop a time and space and self-experience scale. Yeah, so for meditation, same what we do in schizophrenia, yeah, because that's a phenomenological correlate. But again, I think probably what you really want, and let's say for the individualization, when I have a tendency towards depression and are very slow, probably a slow induction technique is not the right thing. So that's where could be potential markers. Yeah, and you can titrate the experience. Yeah, doing the different induction techniques. What is the best one? Yeah, and that will be an individual fingerprinting of the induction techniques. I think that's absolutely key. Yeah, and then with that coming there from the phenomenology, that will definitely give me also some idea about neuronal markers. Of course, I'm not sure, but I don't think that's sort of what we do with the global signal topography. What I expect, of course, is clear. I expect less topographic differentiation in the global signal, meaning all regions are more homogeneously characterized by their global activity component. That's why you don't process the inputs in a more differentiated way, because the brain is literally more synchronized. So that could be potential markers if you can link them to your degree of, let's say, duality, non-duality. yeah, the degree of environment self-distinction, how much you make a difference.
This is a great, this distinction, you know, environmental self is, you know, is across so many other paths that we need to connect. I think this is a very missing area. Joaquin, do you have any questions for Joaquin?
Yes, wow, it's everything very interesting. I was thinking about the relationship between meditation and allostasis, specifically by the modulation of the insular activity. This is a region, the main region of the allostatic interoceptive network, so maybe this can be a hub of influence to meditate and therefore regulate the activity of the insula, therefore regulate the activity of the allostatic interoceptive network, therefore regulate the organism and stabilize the organism. Could this be possible? How is the evidence associating meditation and the activity of the insula? Because that is a question. Because I reviewed that evidence and only 2 papers, one from Tears, made that association. But is that theoretically and scientifically based, meditation and insular regulation?
There is a lot of discussion on the insula, and normally you would have some literature that supports that meditators have more interoceptive awareness, and that will be linked. And that will be linked to an insular connectivity, but there is another So the short answer is yes, but there is still lack of some replicability because of the degree of the training. So normally you have these studies in very advanced meditators that are not real lifestyles that we can achieve living in a city, basically, and with normal jobs and stuff. So, but normally, yeah, you take the best monk, and if that is the case, then yes. And there is a sense of self-sensing and self-regulation in all the models. There is a self-awareness and self-regulation that is increased, and insula participates in this sensing part of the awareness. So I think, and how to relate to allostasis, I think that is something that we have been all thinking. I mean, one stressor will hit you in a very different way, and how your internal system is standing, right? So, and how your internal system is standing, that is, you can train to regulate, to keep some kind of consistency in how to maintain your mental stability or emotional stability. You can train for that. So when you train enough, then the stressors will hit you in a kind of a good shape that you can absorb this, and it's not going to create some critical point that is going to trigger some other, cascade of inflammatory and like that. So you can kind of prepare yourself for allostatic load. But yeah, so that is what I will, yeah.
I am against the idea that insula is a unique or critical point, but we can discuss later. Yeah, yeah. But Ale have a comment. Yeah.
Thanks. I have a two-step question. I'm going to make the first one, and doing the second one, you can compare, because the first one is for you. About this mindfulness, how do you compare the mindfulness effect again, for instance, like hyperfocus, state in asking for a friend in attentional disorder, for instance, or need to be like an inner state?
No. I mean, focus attention, you can use an internal or you can use an external object. And doesn't matter. The thing is that the exercise is to keep your focus on the object of choosing and realize that you distract and come back the attention to that. And doesn't matter if it's external or internal. You can train both of them. But there is also some papers coming from Feldman, and a guy that is very it has a great literature about how the processing of respiratory rhythm and everything, and he's doing a animal model of meditator mice.
that only regulating the, rhythm through some drugs, manipulating only the breathing system, he's making the rat less anxious and perceiving all kind of things. So I would say, sure, I mean, literature shows, and also in meditative styles, you have in external focus and internal focus, and in terms of like cognitive exercise of coming back your attention to the focus will be the same. But of course that there is a link with the breathing that comes from a more bottom-up point of view that is not, that we haven't like separate yet to establish if there is some different efficacy in the training with breathing or with the external object.
And the second one is a short question for all the speakers. If you had to choose like a key word, like a key idea that someone that doesn't know anything like me, for instance, like a viewer can take and make a change in their lifestyle. The most important one, like a short answer. Changing the lifestyle? Yeah, like the most important, like cause effect.
No, I don't think that there is something, because it's something that we have been discussing a lot, the personalization, and one solution is working for one individual, is not working for another. Like mindfulness can be very disruptive for some participant, and can be very helpful. I mean, very healing a lot. So I won't bet for nothing in particular, I would say. Of course, you have the list. We can repeat that, but this is a question. We tend to think this list is universal and can be applied to everybody. And I think that we are going to show in a forthcoming very important paper that the risk factors interacts in a very, Caro is in the paper, interacts in a very different ways in underrepresented population, and the combination of factors for preventing or for causing or for influencing the risk, it change everything. So, yeah. But,
yeah, I think this is a great question. I think one area called behavioral sciences are focusing on that particular area, because the evidence shows that there is a gap between awareness, knowing what is good for you, and doing. So really committed to do that. So then the behavioral sciences are focusing on developing programs that will ensure people will use this understanding and awareness to develop, embark on actual meaningful personalized behavioral change towards healthy lifestyle. So you see that, for example, this is because when we talk about many of the diseases we discussed here today, prevention. There is no prevention. We don't shift people understanding from this type of behavioral changes and early lifestyle factor that could be modified and result in reducing risk. And from there to the current prescriptive type of mind that we have in our country, where we are very much focused on curative approaches of medical, driven many by the commercial nature of our medical system. But I think there is a lot of work to do, is awareness about that particular aspect that you're talking about, because it doesn't really matter how many solutions we develop, how many tools we provide. If people, there is just to like one story of one of my colleagues, actually the director of the Center for Behavioral Changes in Harvard University. I saw the Scottish population asking about how well people were, or bad drivers of brain health, including all these things. So then I'm asking a lot of questions about that. And so the majority of the population were aware of these changes. So but when we ask about, are you ready to go for it? And people say, 50% yes, I would. And when they ask why, they say, well, if I get sick. So you see that the people view is not really prevention, is just cure. And it doesn't people's mind. There isn't a way toward prevention. We don't shift people's view about what is really prevention. Not only people view our health systems, views and approaches to that.
Sorry, we are running out of the time. Last word, Claudia and George. Use the mic.
If I have to choose some word, be happy. And that's it.
Oh, well, I am dumb in that case.
I don't add anything to that.
So thank you so much. Our guests are going to be here in case you want to interact with them, to make questions for today, right? They are both here. So we welcome you to interact with them. They are making collaborations across the globe, so enjoy them. Thank you so much. Muchas gracias y nada. Terminamos. Let's bring to take a picture if you don't mind.